Hello everyone, I'm Big Cat. In the last lesson, we created the function of crosshairs offset. In some cases, it affects the value of crosshairs offset. In this lesson, we correct crosshairs offset. When a weapon is fired continuously, the crosshairs should offset more than when a single shot is fired. How can fire continuously? Judgment is made based on the time between the current firing and the last firing. Judgment is made before the firing time is set. Use the current time minus the last fire time to get the time between fires. Promote it to a variable. Named fire interval. Print this interval time. Run the game. Pick up weapon, pick up ammo, reload. Check the printed time as you fire. I think it is consistent continuous fire if the interval is less than 0.4 seconds. Delete the print. Judgment when setting pitch value. Add select node. Select pin tab as float. Determine if the firing interval is less than 0.4. Connect the result to the index of select. If it is less than 0.4, set the value to 2. If not, set the value to 0.1. Use this multiplier value to multiply by the original vertical offset value. Set to ready pitch. Run the game. Pick up weapon, pick up ammo. Reload. Control the speed first and fire a single shot. Probably remember this offset. Pick up ammo, reload. Press the B button to switch to full auto mode. Press and hold the fire button. You can see that this offset is twice the offset of a single shot. When the weapon is equipped with some accessories, it may affect the crosshairs offset value. Add a function named calculate offset pair. Category as private. It is used to calculate the percentage of weapon accessories that affect the crosshairs offset. Add output parameter, named vertical, and tab as float, indicates the percentage value of vertical. Add output parameter, named horizontal, tab float, indicates the percentage value of the horizontal. Select pair. 3 weapon accessories may affect the crosshairs offset: muzzle, grip, and bastock. Add the sequence node. Determine if the muzzle accessory object is valid. If valid, get the accessory data. Get the vertical and horizontal offset percentage. Promote the vertical percentage to a local variable named vertical pair. Promote the horizontal percentage to a local variable named horizontal pair. Copy and paste. Determine grip. Add the vertical pair value. at the horizontal peer value. Copy and paste. Determine bus torque. Return the vertical and horizontal percentage values. Compile, save. Go back to event graph. Call the calculate offset percentage function. Print. Run the game. Pick up weapon, pick up ammo, reload. Fair. The print value is 0, 0 because the current weapon is not equipped with any accessories. Open my character's event graph. Add the keyboard 1 key. Create a weapon accessory with ID 3. Call the equip accessory function in my player controller. Copy and paste. Respond to keyboard 2 keys. Set the ID to 9. 9 is the vertical grip of M4. SN set to 999. Copy and paste. Response to keyboard key 3. Set the ID to 70, and 70 is the M4's bus torque. SN set to 70 and 70. Compile, save, run the game. Pick up the M4 weapon, pick up ammo, reload. Press 1, press 2, press 3. Fair and print the results as 0.65 and 0.3. Open the weapon accessory data table. Muzzle ID3 has a vertical offset percentage of 0.25 and a horizontal offset percentage of 0.25. The vertical grip ID9 has a vertical offset of 0.25 and a horizontal offset of 0. The vertical offset percentage of the ID17 grip is 0.15 and the horizontal offset percentage is 0.05. Together, the vertical offset percentage is 0.65 and the horizontal offset percentage is 0.3. The function calculates correctly. Go back to item weapons event graph. Before setting the yaw value, multiply it. Subtract the calculated horizontal offset percentage by 1. Then set it to ready yaw. Copy and paste. Before setting the pitch, multiply by 1 minus the vertical offset value. Compile, save, run the game. Pick up an M4 weapon, pick up ammo, reload. Press 1, press 2, press 3, press B to change the weapon to full auto mode. Press and hold to fire. You can see that a fully equipped M4 weapon has very little offset. Add comment. Compile. See you. Hello everyone, I'm Big Cat. Starting from this lesson, let's make the bullet feature. Before we start making it, let's do an overview. The ideal trajectory for a weapon to fire a bullet in a straight line. But in reality, it can be a straight line. The bullet itself will have gravity and air resistance and undirected wind. Let's simplify the process. Maintain the gravity of the bullet. Air resistance we control by continuously reducing the bullet's flight speed, disregarding the undirected wind and other drag forces. The bullet will have an initial speed of flight. In the case of the M4 weapon, the initial velocity of the bullet is 880 meters per second. When the flight distance reaches 100 meters, the speed is 750 meters per second. When the flight distance reaches 300 meters, the speed is 692 meters per second. When the flight distance reaches 500 meters, the speed is 600 meters per second. The final effect is a bullet drop. Create a folder in the blueprints folder and name it bullet. All the blueprint classes related to the bullet are placed in this folder. Create an actor named bullet projectile. Open it. Add the sphere collision component for collision. And replace root. The nose of bullet is very small, so set the circular collision radius to 0.5. To make it easier to see the effect, add a circular model component. Represent the bullet model. In reality, on the one hand, the bullet is very small, and on the other hand, the bullet flies so fast that the bullet is almost invisible to the naked eye. We will delete this mode after this feature is created. Reduce this mode to 0.1. To see the effect better, set material to this sphere and select the material garbage bag tint B. Because this material is red and easier to see, that's all. Add the projectile movement component. This component is a component in Unreal Engine that is specifically used to implement the projectile functionality. When this component is added to the actor will have the functionality associated with projectiles. Next, let's take a look at the functionality of this projectile component. First, let's look at the basic properties of the projectile. The first one is the initial velocity, which indicates the initial velocity after it is created and activated. The unit is kilometers per second. Then comes the maximum velocity, which indicates the maximum velocity value of the character during flight. Unless this value is modified during flight, the actor will never fly faster than this value. The unit is also kilometer per second. If checked, this property will update the rotation area frame, which we can't use. Initial speed is in local space. This is checked by default. This is the gravity scale value. All the properties here are properties to set the boss-related functions of this actor. Our bullet does not need to have a boss effect, so it does not need to be set. Here are the data related to projectile simulation. Just keep the default. Here are the related acceleration attributes. The bullet does not have acceleration effect. Here you can set the interpolation values of various attributes, which we also don't use. This is the velocity value of the vector from of the projectile. We need to modify very few properties and most of the default values will achieve the effect we want. Next, make a bullet to fire when firing. Set the initial velocity and maximum velocity values to 100,000, which means 1000 meters per second. Compile, save. Open the event graph of the atom weapon object. Add the spawn actor node when firing is executed. Class select the bullet through class you just created. Then set the initial position of the bullet. For now, use the center of the screen as the initial position of the bullet. Get the third-person camera object via my character. Get the camera world location. Get the direction of the character forward. Multiply by 100, which is the distance forward 100. This is the initial position of the bullet. Set to location. Get the rotation value of the controller via my character and set it to rotation. Compile, save. Run the game. Pick up a weapon, pick up ammo, reload. Fire. You can see the bullets fired out, and it fired at the center of the screen. Everyone and Big Cat, this lesson continues to refine the bullet function. The initial position of the bullet is different in different states of the current character. There are two types of bullets, with sight on and without sight on. In this lesson, we will create the initial position of the bullet without the sight on. Create a widget in the gameplay folder named main UI. Next, make a simple crosshair. Drag in an image component. Set the anchor point to the center. Select the size to content. Set the image size to 33. Set the x-axis alignment to 1, right aligned. Set y-axis alignment to 0.5, center alignment. The X position is set to -25. Duplicate. The image size is set to 330. The X-axis alignment is set to 0.5, and the Y alignment is set to 1. The X position is set to 0, and Y position is set to -25. Duplicate. Set the Y-axis alignment to 0. Set the Y position to 25. Duplicate. Set the Y-axis alignment to 0. Set the Y position to 25. This completes crosshairs. The crosshair position is 25 in all 4 directions from the center point, which is the value when the character is not holding down the aim and is standby. When firing, the bullet's initial position will be fired at a random point in the area of 25 left and 25 right, 25 up and down. Compile, save. Open my HUD. Create main UI. Add it to the viewport. Compile, save. Next, calculate the initialized position of the unaimed bullet. Open action weapon and add the function getBulletInItTransform. Category as private. Select the peer. Add the output parameter named transform. Tap transform. Get the site state on by my character. Note. Determine if the site state is not currently on. If it is not on, determine whether it is currently holding down the site. Get the forward or backward access via my player controller. If all not equal to 0, get the access to move left or right by my player controller. If all not it is equal to 0, determine if both are equal to 0. Get the crosshair offset value from the weapon data. If the movement is both 0, then it is prone to be done by. Promote the aiming stationary offset minimum value to a local variable named offset min. Promote the aiming stationary offset maximum to a variable named offset max. If the character is moving, the variable is set using the movement value. Determine the same way when aiming is not. Hold down. Copy and paste. Disconnect data. Retain non-aiming offset values. Connect the settings. Add comment. Calculate the final bullet initialized position after the offset value is calculated. Add sequence node. Open event graph and copy the node related to the previous position calculation into the function. Modify the distance to 300. This distance is the distance from the camera as the original. The third-person camera distance from the character is 200, and the approximate loss of a weapon is 100, so it is set to 300 here. Disconnect to set the location. For better readability, copy a MyCharacter object. Next, add the left, right, and up-down offset values. Get the camera object for my character. get the rightward direction from the camera. Add a node with a random float value in a range. Set the minimum and maximum values. Multiply. Add to the initial position. Copy and paste. Delete the camera rightward node. Get the camera up direction node. Set the offset position to transform. Return. Add comment. This completes the calculation of the initial position of the bullet without the sight on. Compile, save. Go back to event graph. Delete the node related to the calculated position. Call the getBullet initial transform function. To see more clearly if the offset position calculation is correct, stop executing screen shake first. Place some cube in the level. Open the bullet class. Set the collision tab to all. Open item weapon. There is a place we wrote wrong before. Compile, save. Run the game. Pick up the weapon, pick up ammo, reload. Fire at standstill. You can see that the initial positions are all within range. Then, test the offset value when moving without aiming. Open MinUI. Change the position value of the cross from the original 25 to 95. Because the maximum offset when moving is 95. Run the game. Pick up the weapon, pick up the ammo, reload. Fire in the moving state. You can see that the initial position is within range. Then, test the offset value when you press aim and are stationary. Open MinUI. Change the position value of the cross from 95 to 10, because the maximum offset when you press aim and stand still is 10. Run the game. Pick up weapon, pick up ammo, reload. Fire at rest. You can see that the initial position is within range. The offsets are all correct when the sight is not on. we will recreate this crosshair UI later. Open my HUD and display the main UI. Compile, save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make the initial position of the bullet when the sight is opened. When the sight is opened, instead of using the crosshair on top of the UI, the weapon's sight is used. The default sight is different for each weapon, so the bullet's initial position varies from weapon to weapon. Each sight accessory also has a different crosshair, so the bullet's initial position is also different when equipped with different sight accessories. We use the skeletal socket to get the bullet's initial position, whether the weapon is equipped with sight or not. Open the skeletal file for the M4 weapon. Add the M4's default sight to the default sight socket. Create a socket in the root BOM named Socket Bullet Default. This indicates the initial position of the bullet when the different sight is in place. Adjust this socket to the sight crosshair. Then drag the x-axis to the position of the muzzle. This can be positioned slightly further forward than the muzzle. Delete the sight model. Add the holographic sight model to the holographic sight socket. Create a socket in the root BOM named Socket Bullet 1X. Indicates the initial position of the bullet when the holographic sight is used. Adjust this socket to the sight's crosshair. Then drag the x-axis to the position of the muzzle. Delete the sight model. Add the 4x sight model to the 4x sight socket. Create a socket in the root BOM named Socket Bullet 4x. Indicates the initial position of the bullet at 4x sight. Adjust this socket to the sight crosshair. Then drag the x-axis to the position of the muzzle. Save. Open the AK weapons skeletal file. Create a socket in the root BOM named Socket Bullet Default. rotate this socket 45 degrees on the z-axis. Adjust the position. Add the holographic site model. Create a socket in the root skeleton named socket bullet 1x. Rotate the z-axis by 45 degrees. Adjust the position. Add a 4x site model. Create a socket in the root skeleton named socket bullet 4x. Rotate this socket 45 degrees on the z-axis. Adjust the position. Save. Open the skeletal file for the AWM weapon. Create a socket in the root bone named socket bullet default. Adjust the position. Add the holographic site model. Create a socket in the root skeleton named socket bullet 1x. Adjust the position. Add a 4x site model. Create a socket in the root skeleton named socket bullet 4x. Adjust the position. Save. Open Atom Weapon. Open the Get Bullet Initial Position function. Add sequence node if set is currently on. Add a local variable named multiplayer. Of type integer. Indicates the current site multiplayer. If there is no site, this value is 0. Determine if the site is valid. If invalid, set the site multiplier to 0, indicates that there is no site. If valid, get the site data. Expand, set the site multiplier to the multiplier variable. With the site multiplier, you can get the socket based on the multiplier. Call the socket position through the weapon model. Add select node. Set the multiplier variable to index. Select the type of pin as name. Add pins, all the V to option 4. Set option 0 to socket bullet default. Set option 1 to socket bullet 1x. Set option 4 to socket bullet 4x. Set to the socket name. Add return. Make transform. Set location. Get rotation by weapon model. Add comment. Compile, save. Next, test. Open my character's event graph. Add the keyboard 1 key. Create a site object with the ID 1. Call the equip accessory function. Copy and paste. Respond to the keyboard 2 key. Set ID to 2. Compile, save. Run the game. Pick up M4 weapon. Open the sight. Fire. Bullets are initially positioned correctly. Press the 1 button. Open sight. Fire. Initial bullet position correctly. Press 2. Open sight. Fire. Bullets are initially positioned correctly. Pick up AWM weapon. Open sight. Fire. Initial bullet position correctly. Press the 1 button. Open sight. Fire. Initial bullet position correctly. Press 2. Open sight. Fire. Initial bullet position correctly. Hello everyone, I'm Big Cat. In this lesson, we are making a bullet drop feature. The bullet will decrease in speed as the distance it travels increases. Open the weapon data table. Each weapon has a different initial velocity and a different deceleration. To see the effect better, we need to add some elements to the level. Add a cube, which is used to measure the distance. Adjust the size. Adjust the position. Add a cube, which will be used as a target. Adjust the size. Adjust the position. Add a cube. This cube is used as a reference. Adjust the size. Adjust the position. Add a cube. Adjust the size. Adjust the position. Save the level. Run the game. Press 2 to equip the sight. Fire. Eject. Double-click on the bullet object. As you can see, there is currently a falling effect. This is because the bullet currently has its own gravity, so that it will have a downward effect. Open the bullet object. The bullet now has an initial and maximum velocity of 1000 meters per second. Set the initial and maximum velocity of the bullet to 500 meters per second. Run the game. Press the 2 button to equip the sight. Fire. Eject. Double-click on the bullet object. As you can see, this time the drop degree has increased a lot compared to last time. This proves that speed also affects the degree of descent. Open the bullet projectile blueprint. Respond to the activation event. This event is triggered when this bullet object is activated. On activation, the current bullet position is obtained and promoted to a variable named init location. Indicates the initial position of the bullet object. Calculate the distance traveled by the bullet in real time in the tick event. Get the current bullet position. Subtracts the initial position from the current position. Call vector length. This is the current bullet flight distance. Promote to a variable named current distance. Add print. Compile, save, run the game. Fire. You can see that the final distance the bullet travels to the cube is 500 meters. Delete the print. Add a comment. Each weapon has a different initial velocity and flat speed, so the velocity needs to be set dynamically. Add variable named init velocity, cap float. Indicates the initial velocity. Select Instance Enabled and select Expose on Spawn. Duplicate the variable and name it 100m velocity. Indicates the velocity when flying to 100 meters. Duplicate the variable and name it 300m velocity. Indicates the speed of flight to 300 meters. Duplicate variable named 500m velocity. Indicates the speed of flight to 500 meters. When the object is activated, convert the object to a projectile component. Set initial velocity. Set the maximum velocity. The initial velocity of the bullet is the maximum velocity. Set the different initial velocity and the different maximum velocity to 0. open atom weapon. Get bullet velocity from weapon data. Set. Add comment. Compile, save. Go back to the bullet object. Next, make a bullet that decreases in velocity as the distance traveled increases. Determine if the current distance is less than or equal to 10,000. Indicates whether the current distance is between 0 and 100 meters. If it is between 0 and 100 meters, add the lerp node. A value is set to initial velocity. B value is set to 100 meter speed. Dividing the current distance by 10,000 gives the percentage of the current bullet's position between 0 and 100 meters. Set to alpha. Set the maximum velocity by calling it from the projectile object. Set the maximum velocity. Copy and paste. If not within 100 meter, determine if within 300 meter. Set lerps A value to 100 meter velocity. Set lerps B value to 300 meter speed. Subtract 10,000 from the current distance first, then divide it by 20,000. Subtracting 10,000 first is shaving off the previous 100 meter distance and then dividing by 20,000 to get a percentage value between 100 meter and 300 meter. Copy and paste. If it is not within 300 meter, determine if it is within 500 meter. Set lerps A value to 300 meter speed. Set lerps B value to 500 meter speed. Subtract 30,000 from the current distance first, then divide it by 20,000. Subtracting 30,000 first is shaving off the previous 300 meter distance and then dividing by 20,000 to get a percentage value between 300 meter and 500 meter. Add a comment. Test the effect of decreasing speed by printing. Printing in tick. Add the append node. Print the current distance first. Get the velocity by the projectile component. Compile, save, run the game. fire at the target backdrop. Open the output panel. The initial speed of the M4 weapon is 880 meters per second. When flying to 100 meters, the speed drops to 750 meters per second. At 300 meters, the speed drops to 692 meters per second. The decreasing speed is correct. Delete the test node. Compile and save. The bullet drop function has been created. That's it for this lesson. Thanks for watching, and we'll see you next time. Hello everyone, I'm Big Cat. In this lesson, we make the bullet hole function. When a bullet collides with an object, a bullet hole is created, and the bullet object is destroyed. The bullet holes are displayed using decals. Let's start by creating a material for the bullet hole. Open the Access, Others, Textures folder. Here, you have a texture of the bullet hole. Right-click and create a material named bullet hole. Drag this material into the Materials folder. Open it. The material domain is default decals. Select Translucent for the blend mode. Blend mode for decals selects debuffer translucent color. Connect the material's alpha to the material's opacity. Apply and save. You can see that the edges of the bullet holes are now transparent. Close. Next, create the bullet hole object. Create an actor in the blueprint bullet folder and name it bullet hole decal. This actor is used to display the decals. Open it. Add the decal component. Set the material you have just made the material of the decal. Set the fit screen size to 0.001. This value is small enough so that we can see the decal from a distance. Set the fit start delay 30 seconds. This means that the decal will gradually disappear 30 seconds after it is created. Set the fit duration to 3 seconds. Transparency is set from 1 to 0 for a total of 3 seconds. The default checkbox is to destroy the decal owner after it disappears. The actor will be destroyed automatically after the feed is executed. Set the size of the decal to 244. Save. Next, generate bullet holes when the bullet hits the object. Open the bullet object. It's a hit event that will be executed when the bullet hits the object. Add a spawn actor node when the object is hit. Set the class to the bullet hole decal class you just created. Make transform. Location is the position that the bullet will collide into. Get the rotation value of the current bullet component. Call the inverse transform rotation node. Get the transform of the object component that the collision has hit. Set this value to t. This gives you the rotation value that the decal should have. Set. Add comment. Destroy on object after collision. compile, save. Next, test the bullet hole. Delete the sphere model, compile, and save. Open Action Weapon. Connect Chic. Run the game. Fair. A bullet hole will be created every time a bullet collides with a location. This bullet hole will last for 30 seconds and then disappear within 3 seconds. The bullet Hello everyone, I'm Big Cat. For this lesson, we are going to create an inventory interface. Here, we will use two fonts that are not the default. You can also use other fonts. Open the font folder in a site. There are 4 fonts here. Importing fonts is very easy. Just drag a font file of type OTF or TTF directly into the engine, and it will automatically generate this file. Create a folder in Blueprints and name it UI. All UIs are placed in this folder. Create a folder named Font. Put the font files into this folder. Create a font object named Avenir Font. Open it. Click on Add Font in the default and select Avenir Bold. Name this font Avenir Bold. Click Add Font and select Avenir Medium. Name this font Avenir Medium. Save, close. Create a font object and name it Big Needle Font. Open. Click Add Font and select Needle Tailing. Name this font BMT. Click Add Font and select Big Needle Tailing for oblique. Name this font BNT Oblique. Save, close. We have created 2 fonts, each with 2 styles. Different monitors have different resolutions, so when creating the UI, we will need to take into account adapting to different resolution screens. Open the Project Settings panel. Select the User Interface option. Here, there is a DPI scaling function. This function is set, and the engine will automatically do the content scaling for us. First, look at the DPI curve. Check this key point, and when the resolution is 1080, the scaling value is 1. This means that when the resolution is 1080, now scaling is done. That is, we are developing at 1080 when we produce. Checking the key point next to it scales 0.666 times when the resolution is 720. Similarly, when the resolution is 480, the scaling is 0.444 times. If the resolution is smaller than 480, the scaling will not continue as we have not set the node. If you want to continue scaling, right-click to add a keyboard to continue adding it. But if it is smaller than 480, it is difficult to see the content clearly, so there is no point. Theoretically, it is possible to support infinite zoom settings. This scaling rule option determines whether the resolution refers to length or width. By default, the first option means that the shooter side takes precedence. The second option is to take the longer edge as the base. The third option is based on the horizontal edge. The fourth option is based on the vertical edge. The last is custom, which we won't cover for now. Create a widget in the UI folder named Test UI. Open it. Set this UI to full screen. The screen size has a lot of parameter values here. Drag them directly, and you can see that there are many screen sizes. select 19201080. All our future UI will be designed with 19201080 in mind. Drag in an image. Set both the width and height to 100. Set the color to red. Duplicate. Drag it to the top right corner. Duplicate. Drag to the bottom left corner. Duplicate. Drag to the bottom right corner. Duplicate. Drag to the middle. All properties are currently on-site except size and position. Compile and save. Next, display this UI. Open my player controller's event graph. Add a show inventory event response. Add the create widget node. Select test UI. Call the add to viewport function. Compile and save. Run the game. Press the pubg key. You can see that the UI is now displayed in the viewport. Next, test the UI scaling. Drag and drop the edge of the game program to scale. First, try to scale down the program in equal proportions. You can see that as long as we are scaling the program window at 69, all the UI contents will be scaled equally and in the correct position. But what happens if you don't scale equally? First, stretch the width. You can see that the content scales to the height. This is fine, but there is a problem with the UI's position. The box in the top right corner is not in the top right corner. The box below is no longer visible at all. The middle box is also not in the middle. Stretch the head. You can see that the content is still scaled according to the head, which is fine. But there is also a problem with the position of the UI. Next, we create a screen adaptation of the UI position. Select an image. In widget, all components have an angles property. This property means angle point. What is an angle point? Let's see this box in the top left corner. We want to make it always aligned with the top left corner of the screen. Then, select the top left corner in the anchors option. This since that looks like a flower indicates the anchor point position. Set anchor point separately. Compile, save, run the game, press the table key. No matter how you zoom the program screen, the boxes will be where we expect them to be. Once you have set this anchor point, you can adapt to more than 8% of the resolutions. If you have a very specific scale, you may need to create a separate set of display positions. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we create the inventory interface widget. Create a folder in the UI folder named Inventory. Create a widget named Inventory UI. This widget is used to display all the content of inventory interface. Open it. Set this UI to full screen. Drag the screen size to 19201080. The background of the inventory UI will have a blur effect. Drag in a background blur component named background blur. Anchor select the bottom right corner. This option is meant to fill the entire screen. This ensures that this background will fill the whole screen, no matter the screen's size. Set blur strength to 5. The UI also has a dark background. Drag in an image component named background color. After the setting name, there is an option to set whether it is a variable or not. If it is true, click on Graph. There is this component in the variables, and it will be possible to program the blueprint here. If false, there is no such component in the variable. This background does not need to be operated on, so we set it to false. Check the Set to Content option. In the brush, set the image size to 1920-1080. The color is set to black, and the opacity is set to 0.55. Compile and save. Open my player controller. Set it to Inventory UI. Run the game. Press the Table key. You can see that the background color is black, translucent, and has a blurring effect. Next, create a function to show or hide the UI. Add a variable named Inventory UI of type Inventory UI Object Reference of category UI Ref. This presents the object reference for the inventory interface. When the table key is pressed, first determine if inventory UI is valid. If it is valid, then it proves that the inventory interface is currently being displayed. Then the inventory interface needs to be closed. The remove from parent function is called using the inventory interface object. The interface is removed from the display object. Then set the variable to none. If the current variable is invalid, then it proves that it is not being displayed. Add the create widget node. Select inventory UI. Set the object to the variable. Call the add to viewport function. Compile, save. Run the game. Press the table key. You can see that the UI is displayed in the viewport. But there are two problems. There is no mouse, and one mouse can still control the viewport rotation of the character. In this interface, the mouse will be needed to interact with some elements. So, the mouse needs to be displayed, and it can no longer control the rotation of the viewport after the interface is opened. Once the interface is displayed, add the Set Input Mode Game and UI node. This node aims to set the input mode, which affects both the game sense and the UI. This widget to focus is the UI object to focus on. Set to Inventory UI object, mouse lock mode is set to always locked. Player controller is set to itself. Deselect Head Cursor during capture. Call the setting Show Mouse Cursor and set to true. After closing the interface, add the Set Put Mode Game Only function. Set the player controller to itself. This function sets the input mode to game sense only, which returns the focus to the sense. Then call set to show the mouse cursor and set it to false. Add comment. Compile, save. Run the game. Press the table key and the mouse is not displayed. And when the mouse is not pressed, moving the mouse does not control the sense rotation. Pressing the table key again hides the mouse, and moving the mouse controls the sense rotation normally. But there is another problem. Press the table key. If the mouse is pressed to move, the sense will still rotate. The next step is to solve this problem. Disable mouse control of the character when the inventory UI is displayed. Find the mouse input area. Get if the mouse cursor is currently displayed. If it is not displayed, continue with the process. Copy and paste. Compile, save. Run the game. Press the table key. At this point, the mouse will not have any effect on the sense if it is pressed again to move. With the inventory UI open, unaim if the character is aiming. Call the reverse hold aiming function after the inventory UI is displayed. This cancels the aiming. Run the game. Pick up the weapon and turn on the sight. Press the table key. You can see that aiming is automatically cancelled. Once the UI is displayed, you need to disable the left mouse button related function. Currently, only the left mouse button is used for firing. Add a judgment after the fire button is pressed. Get the UI update and determine if it is valid. If it is not valid, then execute the logic related to firing. Run the game. Pick up weapon, pick up ammo. Reload. Press the table key. Click the left mouse button, it will not fire. Once the UI is displayed, you need to disable the right mouse button related functions. Currently, only aiming use the right mouse button. Add a judgment after the aiming key is pressed. Get the UI update and determine if it is valid. If it is not valid, then execute the fire logic. Run the game. Pick up the weapon. Press the table key. Clicking or holding down the right. Hello everyone, I'm Big Cat. The inventory UI is complex, and splitting its contents into multiple widget fields and then putting them together will make the blueprint much more readable. Generally, we will start with the smallest element to make a widget. Displaying nearby ground items is the same style as displaying items in your backpack, so you can create an item for reuse. The V items are displayed as a list, with one item representing one item. We call this an item. In this lesson, we will create this item. Create a widget in the inventory folder named iGoods_item. Open it. Set the screen option to desired. This means that the overall size of the widget will be the same as the content. Drag in an image component named item_bg. This image component is used to represent the base image of the entry item. Check the size to content option. Set the size to 225/60. Open the color panel. Set the color value to 707070. Set the A to 0.3. Drag in an image component, name it icon_bg, and uncheck the variable. This image component is used to represent the base image of the icon. Check the size to content option. Set the size to 60/60. Open the color panel. Set the color value to A08080. Set the A to 0.1. Then create a dynamic content display. The dynamic content includes the item icon, the item name text, and the item amount text. Their three items are arranged horizontally. So, drag in a horizontal box which automatically aligns the sub-components horizontally. Set the width to 225 and the height to 60. Drag in an image component named icon. This image component is used to display the item icons. Set the size to 60/60. Then create the display text. The text needs to automatically line fit and vertically centered no matter how many lines it is. Drag in a converse panel. This panel is responsible for the vertical centering. Set the distance to the left to 5. Set the vertical centering. Drag in a size box component. The purpose of this component is to limit the width and height of the text box. Set the width to 130 and the height to 60. Drag in a text box component. This component is used to display the name of the item. Name it name and check its variable. Set the horizontal alignment to left and the vertical alignment to center. Set the font to Avenir font. Set the tab to medium. Set the font size to 12. The font at the back of the page is referred to as font A, and the font at the top of the page is referred to as font B. Then add a little shadow effect to the text to make it more three-dimensional. Set the transparent shade to 1. This will give you a shadow of size 1 and black. Next, create the display amount text. Drag in a text component. Name it amount, and check that it is a variable. Select food for size. When this option is selected, the component will fill all the remaining space. Align horizontally to the right. Center align vertically. Set the text content to 999. Select B font. Tap BNT. Set the size to 30. Set the shade color value to 1. The item interface section is now complete. Finally, add a size box component. Drag it to the top. Set the width to 225 and the height to 172. You can see that there will be a blank space below the effective display area with a height of 2. This is to provide a spacing between each item in the scrolling list. Compile and save. Next, test. Set the icon image to be an emo icon. Set the image size to 60. For the name text, we write a longer name. Compile. Check Auto Wipe test. The test can be automatically line wrapped. Here, the line break will check for space in the text. So, add space in between each word. Set the amount test to 9, and you can see that the number test is aligned to the right. Compile and save. Open Inventory UI. There is a user created in the palette list. All the widgets we have created are shown here. Drag in an item. Run the game. The display is correct. Delete the dragged in item. Compile and save. Next, make the setup data function. Go back to the item widget and open graph. Add a function named setContent. Add an input parameter named itemBase of type itemBase object reference. An input parameter named icon of type texture 2D object reference. Add an input parameter named name of type text. Add an input parameter named amount of type integer. Promote itemBase to a variable. Get the icon component and call the setTexture function. setTexture. Get the name component. Call the setText function. setName. Determine if the number is greater than 0. If greater than 0, get the amount component. Call the setText function. Get the amount parameter and set it to text. If equal to 0, this item does not display an amount value. Set text to empty. Compile, save. The next step is to create the mouse on entry function. This is achieved by modifying the transparency of the background image to show this effect. Override the mouse enter event. Get the background image component and call the setColor and opacity functions. Make linear color. Set both RBG to 0.439216. Set opacity to 0.5. override mouse leave event. Copy, paste. Set opacity to 0.3. Compile, save. Text. The atom widget has been created. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about making a list that displays items on the ground. Create a widget named iVicinity list. Open it. Set the screen option to designed. Drag in a schoolbox component. This component is the list component. Name it item list and check its variable. Set the width to 232 and the height to 810. Open the style. You can see the top and bottom shadows. We are currently choosing a vertical layout, so when we can scroll up, the top shadow will be displayed, and we can scroll down, the bottom shadow will be displayed. Here, we don't need a shadow to be displayed. Set the top shadow to none and the bottom shadow to none. Turn on the scroll bar style. This shows the background line of the scroll bar below the slider when it is oriented vertically. This shows the background line of the scroll bar above the slider when oriented vertically. Neither of these lines is needed. Set to none. The color value of the slider in each state is set to 939493. Set the width of the scroll slider to 5. Whatever the height, it will not affect, as it will vary with the amount of content. Set the scroll bar distance from the left to 2 and the other side to 0. Checking this option will make the scrolling smaller when scrolling. Event needs to be sent when an item moves in or out of the player's pickup range and listened for in this widget. Updating this list display. Open my player controller. Create an event dispatch named event item change in range. This event is fired when the item array changes within the pickup range. Open the exact begin overlap function. This function is triggered when an item enters the range. Turn on the exact end overlap function. This function is triggered when an item is moved out of range. Compile and save. Go back to the vicinity list widget. Go to Graph. After the widget has been successfully created, get the player controller and convert it to my player controller. Point the item change event in the range. Create an event. Create a function named updateList, used to update the list display. Go back to Event Graph. Set the function. Call the updateList function once when the widget has just been successfully created. Add a distract event. This event will be called when the widget is to be destroyed. The distract event of the parent class is called first. Then unbound the item change event in the range. Compile and save. Next, complete the updateList function. Open the function. Update the list before each update to the list. Get the list object and call the empty all child objects function. Get the array of items that are in range via my player controller. Loop array. Add sequence node. Get the number of items promoted to a local variable, name it amount. Get the item type switch. If a weapon converted to weapon pickup object. Get datas expand. Keep name and icon properties. Promote name to a variable. Name it name. Promote icon to a variable. Name it icon. Weapons don't need to display amount, so set amount to 0. If it's a weapon accessory, convert it to a weapon accessory pickup object. Same setting. If ammo, convert to ammo pickup object. Same setting. If health, convert to health pickup. Same settings. If burst, convert to burst pickup. Same settings. If helmet or vest or backpack, convert to equipment pickup. Same settings. Once the data is ready, create the item widget. Add the create widget node and select iGoods item. Call the set content function. Set item base, set icon, set name, set amount. Call the add child object function via the list. Set the created widget to content. Compile, save. Next, build the UI related to the vicinity ground items in the asset interface. Open the designer screen of the inventory UI. Drag in a vertical box named vicinity box. Check the size to content. Drag in a text. Set the display content to vicinity. Set the color to B0AEAD. The font is set to B, the tab is BNT, and the size to set to 28. Drag in a text. The display is set to ground. The color is set to CFCDCB. The font is set to A, the tab is bold, and the size to set to 12. Drag in a vicinity list widget. Uncheck the variable. Set the top margin to 5. Compile, save. Run the game. Press the table key to open the inventory UI. Move the character. The list is lesson. Hello everyone, I'm Big Cat. This lesson is about making a display of backpack items. Create a widget in the inventory folder named iBackpackList. Open it. Set the screen options to desired. The backpack list is the same size and style as the vicinity items list. So, open the vicinity list widget. Copy the list. Go back to the backpack list and paste it. This list shows the items in your character's backpack. When an item in the backpack changes, listen in this widget and update the display of this list. After the widget has been successfully built, get the player state through the player controller and convert it to my player state. Point item change event. Create the event. Choose to create a matching function. Name it update list. call the updateList function once when the widget has just been successfully created. Add the distract event. This event will be called when the widget is to be destroyed. The distract event of the parent class is called first. The unbound the atom change event. Compile and save. Next, complete the updateList function. Open the function. Empty the list before each update to the list. Get the list object and call the empty all child objects function. Get the player state via player controller. Convert it to my player state. Get an array of all items in the backpack. Loop the array. Add sequence node. Get the number of items promoted to a local variable. Name it amount. Get the item type. Switch. Only weapon accessory, ammo, health, and burst will be in the backpack. No other items will appear in the backpack. If it is a weapon accessory, convert it to an accessory weapon object. Get datas. Expand. Keep name and icon properties. Promote name to a variable and name it name. Promote icon to a variable named icon. Weapon accessories don't need to show amount, so set amount to 0. If ammo, convert to ammo object. Get datas expand. Set name variable. Set icon variable. If health, convert to health object. Get datas. Expand. Keep name and icon properties. Set the name variable. Set icon variable. If it is a burst, convert it to a burst object. Get the datas, expand them, and keep the name and icon properties. Set the name variable. Set the icon variable. Once the data is ready, create the item widget. Add the create widget node and select iGoods item. Call the setContent function. Set item base, set icon, set name, set amount. Call the addChild object function via the list. Set the created widget to content. Compile and save. Next, build the UI related to the backpack items in the inventory UI. Open the inventory UI. You need to display two text boxes and a list of items, and it is displayed vertically. So use a vertical box for the layout. Drag in a vertical box and name it backpack box. Check the size to content. Copy and paste the two text box in the same style as the two text box for the vicinity items. The first text is set to inventory. The second text is set to backpack. Drag in the backpack list widget. Uncheck the variable. Set the top margin to 5. Compile and save. The backpack items UI is linked up horizontally with the vicinity items UI to create a horizontal box. Drag in a horizontal box and name it items box. Check the set to content. Drag the vicinity box and backpack box into the horizontal items box. A dividing line is required. Drag in an image component and drag it to the middle. Set is not a variable. Set the width to 1 and the height to 808. Vertical layout is set to top. Set the color value to 5755553. Set the distance from the left to 30, the top to 70, and the right to 13. Select the horizontal component, set the anchor point to center, set the X position to -850 and the Y to -450. Run the game. Pick up the items. Press Table to open the inventory UI. Move character. Hello everyone, I'm Big Cat. In this lesson, we are making a backpack capacity bar to show how much space is left in the backpack. Use the progress bar component to make this capacity bar. This bar is positioned horizontally with the backpack box. Add a horizontal box and drag the backpack box into it. Drag in a progress bar component. Name it backpack capacity bar. Set the vertical layout to line up. Set the fill bar to fill from the bottom to the top. The progress bar has 3 images. The first is the background image. The second is the fill image, which is the progress image. The third is the border pattern image. We need to set all 3 of these images to the same size. Set the width to 8 and the height to 190. Set the background image color to 444544. Set the fill color to FFFFF. Adjust the percentage to see the change in the fill bar. Set the distance from the left to 20 and the top to 360. Compile and save. As with the backpack list, you need to listen for events that change the items in the backpack, and then update the capacity bar's display. Open the backpack list UI and copy the listening blueprint. Paste into the inventory UI graph and link to construct. Create a matching function named update backpack capacity bar. Select this function. Execute an update when the UI is created. Add distract event. First, call the distract event of the parent class. Then, onboard the item change event. Compile, save. We need 2 values, one for the total backpack capacity and one for the total weight of the items currently in the backpack. These 2 values were calculated in the previous lesson. Open the check backpack capacity function in my player state. It has already been calculated here. It just needs a simple modification. Check all nodes related to calculating the total capacity. Right-click and collapse them into a function named backpack total capacity and category backpack. Add the output parameter named capacity value and of type integer. Promote total capacity to a local variable. Add sequence node. Return the capacity value when the calculation is complete. Compile and save. Return to the check backpack capacity function. Select all nodes related to calculation the total weight of items, and right-click to collapse them into a function named items total weight, category backpack. Select peer. Add the output parameter named weight, value, type integer. Promote items weight to a local variable. Add sequence node. Return the capacity value when the calculation is complete. Compile and save. Return to the check backpack capacity function. Remove sequence node. Replace the atom weight variable with the atom's total weight function. Replace the total capacity variable with the backpack total capacity function. Compile and save. Open the update backpack capacity bar function. Get player controller. Get player state. Convert to my player state. Get the current total weight of all items. Get the total backpack capacity. Divide the two numbers. Note here that you need to use a float type of division as we need float. Get the backpack capacity bar and call the set percentage function. Set the percentage. Compile, save, run the game. Open the inventory UI when there are no items in the backpack. Pick up the item, then check. Lesson. Hello everyone, I'm Big Cat. This lesson is about making an equipment item widget. All the equipment boxes have the same style, so a common widget. Create a widget in the inventory folder named iEquipmentItem. Open it. Set the screen option to desired. The border component aims to give its children a border that can be used to display border functionality. Check the Set to Content option. As there are multiple components to be placed under the border, an overlay component needs to be placed. The purpose of this component is to have multiple components overlapping each other. The equipment box has two backgrounds, one without the equipment and one with the equipment. The background with the equipment is a little darker. Drag in an image component named pubg now to indicate the background image when there are no items. Set the image size to 60. Set the transparency to 0.4. Copy this image component and name it pubg to indicate the background image when there are items. Set the transparent one to 0.6. Then set the borders. Set the top and bottom left and right margins to 1. This is the size of the border. Set the color value to 4D, 4F, 4F. And the transparency to 0.5. Drag in an image component named icon, which will be used to display the equipment icon. Set the size to 60. The interface is now complete. Compile and save. The type of equipment differs from one to another. The equipment all use this one widget, so it is necessary to distinguish each component's type. Create an enumeration file in the data's enu folder, named inventory location. Open it. Edit, showing the name as none, indicating null type. We only have 6 parts that can be equipped, and for the sake of good layout, we will put in 11 equipment boxes. So, some just don't have substance. Just select this option. Add name helmet. Add name vest. Add name backpack. Add name close top. Add name close bottom. Add name shoes. This will be used for now and will be added later. Save and close. Open the graph in the equipment box. Add the variable name location with the type of the enumeration just created. Check editable instance. Check spawn. Compile and save. Next, listen for equipment and fashion change event. After the widget has been successfully built, determine if the location is null. If it is null, get the background component, call that visibility, and set it to hidden. Get the icon component, again set to hidden. If it is not null, bound the equipment change event. Get the player state via player controller. And convert it to my player state. Bound the equipment change event. Create a custom event named event equipment changed. Get the position if it is a helmet or a vest or a backpack. Determine. Add a function named updateShow, used to update the display. Call this function. Bound fashion change event. Create a custom event named event fashions changed. Copy and paste. Set to top, bottom, shoes. Call the update display function on creation. Add distract event. First, call the distract event of the parent class. Copy and paste to determine if it is null. If not null, unbound the equipment change event. Then unbound the fashion change event. Compile and save. Next, make the update display function. Add the sequence node. Determine if it is a helmet or a vest or a backpack. If it's one of these, it's a piece of equipment. Get the myPlayerState. Get the equipment array. Loop through the array. use a node that can break out of the loop. Compare the position of the equipment in the array. Get the item type if it is a helmet. And current equipment bar is also helmet. Determine. If yes, promote the equipment to a variable named item base. After finding the corresponding equipment, break out of the loop for better performance. Copy and paste. Change the type to list. Set item base. Connect to breakout of the loop. Copy and paste. Change the type to backpack. Set item base. Connect to backout of the loop. If it's an equipment bar, the data is judged complete. If it's not equipment, it's fashion. Fashion is judged in the same way as equipment. Copy and paste. Here, instead, get the fashion array. Call the loop node again. Convert to a fashion item object. Get the fashion tab. Is it a top or is it a bodysuit? This is because the bodysuit will be displayed in the place of the top. Change here to determine pants. Here it is changed to determine shoes. Once the data has been obtained, start setting up the component display based on the data. First, determine if the item base is empty. If it is empty, then the corresponding item is not found. Get the background component and call set visibility. Set to hidden. Get the icon component and set it. Get the background component when there is no item, call set visibility. Set to show. If the object is not empty, you can set the component to show. Add sequence node. Get the item-based object, convert to an equipment object. If conversion succeeds, get data. Extend. Promote icon to local variable. Named item icon. If conversion fails, convert to a fashion object. Get data, expand, set icon to a variable. Set background component to hid when no item. Set background and icon to show. Get the icon component, call the setTexture function. Set the item icon to texture. Finally, set the item-based object to empty on each update. Compile, save. Open the item widget. Copy the input entry and move out event-related content over. Set both RGB color values to 0.01 and transparency to 0.6 on mouse in. Set the RGB color value to 0 and the transparency to 0.6 when the mouse is moved out. Hello everyone, I'm Big Cat. This lesson is about building the equipment-related UI in the inventory. Open the inventory UI. Name it horizontal box. Let's start by making the equipment column. Drag in a vertical box. Named equipment box. Set the distance to the left to 10. Drag in an equipment box named helmet item and uncheck variable. Set the distance to the left to 185. Set the location to helmet. Drag in an equipment box. Name it backpack item and uncheck variable. Set the distance to the top to 150. Set the location to backpack. Drag in an equipment box. Name it width item and uncheck variable. Set the distance to the left to 5. Set the location to width. Drag in an equipment box. Name is none1 and uncheck variable. Set the distance to the left to 5. Set the location to none. This equipment item does nothing. It is just for looks. Next, make the fashion column. Drag in a vertical box. Name it fashion box. Set the distance to the left to 470. Drag in an equipment box. Name it none2 and uncheck variable. Set the distance to the left to 185. Set the location to none. Drag in an equipment box. Name it close top item and uncheck variable. Set the distance to the left to 5. Set the location to top. Drag in an equipment box. Name it none3 and uncheck variable. Set the distance to the left to 50. Set the location to none. Drag in an equipment box. Name it none4 and uncheck variable. Set the distance to the left to 5. Set the location to none. Drag in an equipment box. Name it non-file. An unchecked variable. Set the distance to the left to file. Set the location to none. Drag in an equipment box. Name it close bottom atom and unchecked variable. Set the distance to the left to 120. Set the location to pants. Drag in an equipment box. Name it shoes atom and unchecked variable. Set the distance to the left to 70. Set the location to shoes. Compile, save. Run the game. Pick up some equipment. It's for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about making a weapon item widget. Create a widget in the inventory folder named iWeaponItem. Open it. Set the screen option to desired. Drag in an image component named Weapon Image. Use this display weapon thumbnails. Select the size to content. The size is set to 490, 210. Set the image to thumbnails M4. There is a line of weapon information above it, and this line of components is horizontally aligned. Drag in a horizontal box. Name it top box. Check its variable. Check the size to content. Let's start by making a location box. Drag in a border component named location border. Set the top. Set the border size to 1. Set the color value to A3, A7, A7. Drag in an overlay component so that the components can overlap. Add an image component. Set the size to 30, 30. Set the color value to 0405, 05. Add a text component named location ID. Check its variable. Set the horizontal alignment to center and the vertical alignment to center. Set the default text content to 1. Set the font to A. Set the font type to medium. Set the font size to 60. This position box is not complete. Next, create a name display. Drag in a size box and name it name size box. Check override width and set the value to 65. The effect is to limit the width of the text box to 65. Drag in a text component named name text with variable checked. Set the distance from the left to 30. Align horizontally to the left and vertically to the top. The default display is M416. Set the font to B. Set the font type to BNT. Font size is 24. Set the shadow transparency to 1. Then, create a bullet type display area. You need to display a bullet icon and a text description, both of which are aligned vertically. Drag in a vertical box. Named bullet type box. Set the distance from the left to 280. Drag in an image component and uncheck the variable. Set the distance from the top to 3. Align horizontally to the right. Set the image to bullet icon. Add a text. Name it bullet type text and check variable. Set the distance from the top to 4. Set the default text content to 5.56 mm. Set the font to A. Set the font type to medium. Set the font size to 11. Set the shadow transparency to 1. Next, create a display of current number of bullets in the magazines. First, drag in a size box named clip amount box. Set the distance from the left to 60. Check the overline width and set the value to 25. Drag in a text component named clip amount text and check variable. Set the horizontal alignment to right. Set the vertical alignment to center. Set the default text content to 30. Set the font to B. Set the font tab to BNT. Font size is 24. Set the shadow transparency to 1. Finally, create text to display the number of bullets of the same tab in the backpack. Drag in a text component. Name it remaining amount text and check the variable. Set the distance to the left to 4. Set the distance from the top to 13. Set the horizontal alignment to left. Set the default text content to 110. Set the font to B. Set font tab to BNT. Set font size to 30. Set the font color value to 919191. Set the shadow transparency to 1. Compile, save. Check the location component. After the text, click bound. We can bound a function to list text or bound a variable. Go to graph and add a variable named location and of type text. Go back into the designer and select the location variable. This bounds this text value to the location variable. Why wasn't this type of bounding used before? Because it could be executed once per frame, which could affect performance if it was a more complex function. Open graph. We need to listen for weapon change events and update the display. Get the player controller. Get the player state and convert it to my player state. Promote it to a variable and name it my player state. Bound the weapon change event. Create a matching function named updateShow. Select this function. Perform an update show when the UI is created. Add a distract event. First, call the distract event of the parent class. Then unbound the weapon change event. Compile and save. Next, make the update display function. Open the function. There are two things to do it total. One thing is to find the corresponding weapon object, and then set the display corresponding to the object. Add the sequence node. Determine if the current location is 1. If it is 1, it means it is the left weapon on the back. Get the weapon 1 object via my player state. Determine if it is valid. If valid, promote it to a variable, name it item weapon. If invalid, get the handheld weapon object via my player state. Determine if the object is valid. If valid, determine if the location of the handheld weapon is equal to the left. If so, set the handheld weapon to item weapon. If the current UI location is not 1, then it is 2. When we find the weapon object on the right side of the back in the same way as on the left, copy and paste. Here, it changes to get weapon 2. Here, it changed to get right side. Add a comment. Then set the UI display. First, determine if the item weapon object is valid. If it is valid, add the sequence node. Get the top box component and call the setVisibility function. set it to visible. Get the weapon image component and call set tint color. Make select color. Set the color to white and the transparency to 1. Go through the weapon object. Get the data and expand it. Keep the name, thumbnail, and the ID of the bullet used. Get the name text component. Set text. Get the weapon image component. Set texture. Add get data table row node. Select date table as bullet date table. Set the bullet ID. Expand the data, keeping the bullet name. Get bullet tab text component. Set text. Get current bullet content text complement. Set text. Get the number of bullets by weapon object. Set to text. Finally, set the number of bullets used for this weapon in the backpack. Get the weapon data through the weapon object. Expand it and keep the bullet ID used. Add select node. Using the bullet ID as index. Add pin. Get the current number of 556 bullets via my player state. Set to index when the value is 1. Get the current number of 762 bullets via my player state. Set to the index value of 2. Get the remaining number of text components and set text. Set the return value to text. Add comment. If the weapon object is invalid, it means that the corresponding weapon is not equipped. Get top box. Call set visibility. Set to hidden. Get the weapon image component and call set tint color. Make select color. Set the color to white and the transparency to 0. This hides the image without affecting the image's ability to accept clicks. This will be needed later when the drag and drop function is created. Add a comment. Set the item weapon object to empty before each update. Compile and save. The weapon item widget is now complete. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about creating the weapons area of the inventory UI. Open inventory UI. The weapon area is vertically, so drag in a vertical box named weapon box. Drag in a weapon item named iWeaponItem1 and uncheck variable. Open the weapon item widget. Check the location variable, set editable, and spawn. Go back to the inventory UI. Set location to 1. Drag in an image component. Uncheck variable. Used to display the split. Set the distance from the top to 6. Set the distance from the bottom to 20. Set the height to 1. The width doesn't now need to be set, as it is filled in. Set the transparency to 0.2. Drag in a weapon item. Name it iWeaponItem2 and uncheck variable. Set location to 2. Drag in an image component. Uncheck its variable. This is used to display the dividing line. Set the distance from the top to 6. Set the height to 1. Set transparency to 0.2. Duplicate the image component. Set the distance from the top to 200. Set the transparency to 0.1. The last line separator is made up of 2 images. Drag in a horizontal box. Set the distance from the top to 200. Drag in an image component and uncheck variable. Set the horizontal alignment to left. Align vertically centered. The width is 230 and the height is 1. Transparency is 0.1. Duplicate this component. Distance from the left is set to 25. Horizontal alignment is set to the right. The weapon area is finished. Compile and save. Run the game. Pick up a weapon. Pick up ammo. Open the inventory UI. Weapons are displayed correctly. Close the inventory UI and reload. Open the inventory UI. The number of bullets is displayed correctly. Close the inventory UI. Pick up another weapon. Open the inventory UI and the display is correct. Select weapon box. Set the distance to the left to 80. Compile and save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about making a display of weapon accessories. Create a widget in the inventory folder named iAccessories item. Open it. Set the screen option to desired. Drag in a size box for size control. Check the size to content. Check overline width with a value of 60. Check overline height with a value of 60. Drag in an overline component. Drag in an image component named BG. This is used to display the background image. Set the size to 60. Set the color value to 7F. Set the transparency to 0.15. Drag in an image component named icon, used to display icons. Set an icon as a preview. The widget for the weapon accessory is complete. Compile and save. Open graph. Let's start by adding a few variables. Add the variable named ACC tab. End of tab weapon ACC tab indicates the tab of this accessory. Check editable. Check spawn. Add a variable named owner of tab item weapon indicates the weapon object for this accessory. Add a variable named ACC of tab item weapon ACC indicates the weapon accessory object corresponding to this component. Compile. We need to listen for weapon accessory change events and then update the display. Get the player controller. Get the player state and convert it to my player state. Bound the weapon accessory change event. Create a matching function named updateShow. Select this function. Add the destruct event. Call the destruct event of the parent class. Then unbound the weapon accessory change event. Compile, save. Next, make a function that lights up when the mouse enters and restores when the mouse moves out. Open the item widget. Copy the contents of the input entry and move out event. Set the RGB color value to 0.49839 for both. Set the transparency to 0.3 on mouse enter. Set transparency to 0.15 on mouse out. Get the accessory object and determine if it is valid. Only perform a move enter color change if an accessory is present. Do the same for move out, copy and paste. Compile and save. Next, make the update display function. Open the function. First, determine if the weapon object it belongs to is valid. If it is not valid, the component does not need to be set. If it is valid, add the sequence node. Get the accessory tab switch. If it is a site, get the site object via owner and set it to the ACC variable. If muzzle, get muzzle object via owner set to ACC variable. If it is frigate, get the frigate object via owner set to the ACC variable. If it is a magazine, get the magazine object via owner and set to the ACC variable. If it is a bath duck, get the bath duck object via owner and set to the ACC variable. Then, determine if the accessory object is valid. If valid, get the icon component and call the setVisibility function. To set it to visible. If not valid, call the setVisibility function and set it to hidden. If valid, call the setTexture function of the icon. Get the data via the accessories object. Expand it and keep the icon. Set texture. Update function complete. Compile, save. Adding a weapon accessory item widget to a weapon item widget. Next, add the weapon item widget to the weapon item widget. Open the weapon item. Add a canvas component named ACC Canvas panel with the variable selected. Select the set2content. Drag in a weapon accessory item widget named ACC site. Set the X position to 280 and the Y position to 10. Check the set2content. The accessory tab is set. The following 4 accessories are placed horizontally, so drag in a horizontal box. Set the Y position to 148. Check the set2content. Drag in a weapon accessory widget named ACC muzzle. Set the accessory tab to muzzle. Drag in a weapon accessory widget named ACC frigate. Set the distance to the left to 50. Set the accessory tab to free grip. Drag in a weapon accessory widget named ACC match. Set the distance to the left to 60. Set the accessory tab to magazine. Drag in a weapon accessory widget named ACC bastock. Set the distance to the left to 135. Set the accessory tab to bastock. The interface is completed. Compile and save. Next, update the weapon accessory display when you update the weapon. Open graph. Open the update show function. When setting up the display, get the accessory container and call that visibility. Set to visible. When setting hid, set to hidden. Add a sequence node before setting show. Start by setting the display of the weapon accessory. Add the sequence node. Get the site component and call set owner variable. Set the item weapon. Call the update show function. Copy and paste. Change to the muzzle component. Copy and paste. Change to the free grip component. Copy and paste. Change to magazine component. Copy and paste. Change to backstock component. Add comment. Set the tab correctly. The number of accessories that can be equipped varies from weapon to weapon. If an accessory cannot be equipped, head the corresponding component. Determine if the current open object is valid. If it is valid, get the free grip component object and call set visibility. There are variables in the weapon data to determine which accessories can be equipped. Get the weapon data, expand it, and keep the whether the free grip can be equipped and whether the backstock can be equipped variables. Add a select node. Set the can free grip variable to index. Select the pin tab as select visibility. Set to hidden for false and visible for true. Set. Copy and paste. Change the component to backstock. Set the can equip backstock variable to index. Only these two components need to be judged, as all weapons can be equipped for the other three components. Add comment. Compile and save. Next, test. Open my character. The previous lesson made creating weapon accessories. If you delete them, take a look at the blueprint I have here. Run the game. Pick up two weapons. Open the inventory UI. You can see that the M4 can be equipped with all accessories, so all the accessory boxes are shown. The AWM can only be equipped with 3 accessories, so the other 2 accessory boxes are hidden. Press 1 and the weapon is equipped with a sight, which is displayed correctly. Press 2 to change a sight. Lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. Starting with this lesson, we create a 3D character that is displayed in the middle of the inventory UI. This 3D character can display all the character's equipment, fashions, and weapons at the same time. We use the Scenes Capture feature provided by Unreal Engine to make it. Create a blueprint in the inventory folder and entry Scenes Capture 2D. Select Scenes Capture 2D with the name Capture Actor. This actor is used to capture the character's 3D image. Open it. A capture component has been created for us by default. Create a skeletal mesh to display the skeletal model of the character to be imaged. Set the model to SKM female, which is the same as our character model. The animation mode is set to use the animation aside, and the animation is set to normal stand idle. The animation blueprint created earlier is not used here, because it is not necessary to synchronize all the character's movements in the inventory UI. Set the Z-axis rotation to 90 degrees. This allows the character to be facing the camera squarely. Set the X-axis position to 127 and the Z-axis position to -95. Select the capture component. Click on Texture Target and select Render Target to create a render target. The file is created in the Blueprint UI inventory folder and named T-Character Render Target. Open this texture, and you can see that the default size of the mapping is 256. Set this size to 470, 860. The size determines this size in the inventory UI. You will be shown how to adjust this size visually later. Back in the Capture Actor, set the camera position method to orthogonal mode. Here, we only need to see the character on the front and not see anything other than the character, so we can use orthogonal mode. The larger the value, the more the camera will see, and the smaller the character will be. You can adjust this value yourself for testing. The imaging function is now complete. This is the end of the character creation for now. Compile and save. We have created a texture. We still need to create a material. The next step is to create a material. Find the texture, right-click, and create a material named Matte Character Render Target. Open it. Set the material's domain to UI. Set the blend mode to translucent. Call 1- node with opacity. Set to opacity. Apply and save. Next, create a 3D character widget. Create a widget in the inventory folder named i3D character. Open it. Set the scenes option to desired. Drag in an image component and uncheck variable. Use to display the 3D character. Check the size to content. Set the size to 470, 860. Set the image to the material you just created. The widget is finished. Compile and save. Next, place the widget in the inventory UI. Open the inventory UI. Drag the 3D character widget into the horizontal box and behind the equipment box. Uncheck the variable. Check the fashion box and set the margin to 0. Compile and save. The character is now ready to be displayed on the inventory UI, but it is not dynamic. This is because the actor we captured the image for has not been created into the level. Open the graph of the 3D character. When the widget is created, add the spawn actor node. Select Capture Actor for class. Make transform, and since this actor is not needed to be seen in the level, set the coordinates larger and set the z value to -1 million. Set the z-axis to rotate by 84 degrees. The rotation of this value is to adjust the angle at which the character is exposed to the sunlight. Promote the return object to a variable named Capture Actor. Get the Capture Actor object when the widget is destroyed and call the destroy function. Compile, save. Run. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. All the functions needed for the 3D character are already implemented in my character, so most of them we just need to copy and paste directly from my character. In this lesson, we create a synchronized equipment display. Open the equipment item widget. And copy the bound equipment change event and unbound event. Paste them into the capture actor. Add the distribute event, which will be triggered when the actor is distributed. Promote player state to a variable named myPlayerState. Add a function named updateEquipment. Call this function when there is a change in equipment. Also, call this function once on initialization. Compile and save. The equipment displayed in this actor does not use the objects in my player state. It needs to be regenerated from the objects in player state, and this new object is only used in this actor. Add a function named spawnActor. This will be called when the actor is created. Add an input parameter named itemType of type eItemType. Indicates the type of item to be created. Add an output parameter named itemBase of type itemBase. Add a spawnActor node. Class set to itemEquipment. Add an input variable named ID of type name. Add an input variable named SN of type string. Set ID and SN. Set amount to 1. Switch item type. If it is a weapon, change class to item weapon. Get ID set. Get SN set. Make transform. Returns the created object. Copy and paste. Connect weapon accessories. Set class to item weapon ACC. Copy and paste. Connect helmet, vest, and backpack. Set class to item equipment. Copy and paste. Connect fashion. Set class to item fashion. Compile and save. Once the object has been created, it needs to be attached to the character, so an attach function is needed. Add a function named attach. Add an input parameter named item of type itemBase. Add an input parameter named socketName of type name. Open my character's attach function exactly as this one. Copy the contents of the attach function from my character. Set mesh to skeletal mesh. Compile, save. Open the updateEquipment function. Add a variable named helmetObj of type itemBase. Indicates the object of the helmet. Add a variable named vestObj of type itemBase. Indicates an object for a vest. Add a variable named backpackObj of type itemBase. Indicates an object for a backpack. Open the update display function for the equipment item widget. Copy the blueprint related to the loop equipment. Go back to capture actor and paste. delete brick, delete judgment location, delete the set item base variable, call spawn actor function, set the item type to helmet, set ID, set SN to 3D character helmet, set to helmet obj variable, copy and paste, set ID, set SN to 3D character vist, set item type to vist, set to vist obj variable, copy and paste, set ID, set SN to 3D character backpack, set item type to backpack, set to backpack obj variable, go back to event graph, get the game instance object reference at event begin play as the socket name is needed, get game instance, convert to my game instance, promote to a variable named my game instance, open the update equipment function, call the attach function after the object has been created, set the item, get the helmet socket name via game instance, copy and paste, set item, and get the name of the vist socket. Copy and paste, set item, and get the name of backpack socket. Need to determine when the equipment update is complete. If helmet is equipped, the hair needs to be hidden. Add sequence node. Get the helmet object and determine if it is valid. Open my character and copy all submodes of the character. If valid, get the hair object and call the set visibility function. Set to hidden. If not valid, call the set visibility function. Set to visible. Compile and seal. To avoid duplicate display of equipment, all previous equipment needs to be cleared before each equipment update. Add function named clear equipment. Add sequence node. Get the helmet object and determine if it is valid. If it is valid, call the destroy function. Set the object to empty. Copy and paste. Object changes to vist. Object changes to backpack. Compile, seal. Open the update equipment function and call the clear equipment function before updating the equipment. Open event graph. Call the clear equipment function when the widget is destroyed. Compile, seal. Open the update equipment function. I just made a mistake here. It should be set to helmet. Compile, seal. Run the game. Pick up the equipment. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make display fashions. Open Capture Actor. Set all model position and rotations to 0. Compile. Next, initialize these skeletal meshes. Add the function named initSkeletalMesh. Open my character's initialize skeletal mesh function and copy everything. Go back to Capture Actor's initialize skeletal mesh function and paste. Promote the skin material to a variable. Change the mesh to skeletal mesh. Delete the function. Compile, save. Open event graph. Call the initialize skeletal mesh function when this actor starts executing. Next, make the getFashionData function. Add the function named getFashionData. Add an input parameter named ID of type name. Add an output parameter named skeletal mesh of type skeletal mesh. Add an output parameter named mask texture of type texture. Open the getFashionData function of my character. Copy all the contents. Paste into Capture Actor. Compile and save. Next, make the update fashion function. Add the function named replace skeletal mesh. Add an input parameter named fashion tab of type eFashion tab. Add an input parameter named ID of type name. Open the replace skeletal mesh function of my character. Copy all the contents. Paste into Capture Actor. Connect the fashion tab. Connect the ID. Delete adjust character Z value. Open the initialize skeletal mesh function. Call to update fashion. ID set to 0. Compile, save. Open the replace skeletal mesh function. Promote SKM and mask to local variable. Compile. Run the game. Open the inventory UI. The character's default underwear can be displayed correctly. Next, listen for fashion change event. Open the equipment item widget and copy the bound fashion change event and the unbound fashion change event. Paste them into the Capture Actor. Add a function named updateFashion. Call this function when the fashion item changes. This function is also called once initialization. Compile and save. Open the updateFashion function. Get player controller. Get player state. Convert to my player state. Get all fashion objects. Loop. Call the replace skeletal model function. Converts objects to fashion item objects. Get the fashion tab and set it. Get the ID and set it. All fashions should be cleared before each update. Add the sequence node. Call the update skeletal mesh function. Set the tab to top and the ID to 0. Call the update skeletal mesh function. Set the tab to bottom and the ID to 0. Call the update skeletal mesh function. Set the tab to whole and ID to 0. Call the update skeletal mesh function. Set the tab to shoes and ID to 0. Compile and save. Run the game. Pick up the fashion. Open the inventory UI. Display is correct. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are going to create a display of weapons and weapon accessories. Let's start by creating the play gun holding animation function. Open the event graph of Capture Actor. Get the current character's gun state in real time in a tick. Then play the animation according to the different states. Get the player character and convert it to my character. Add a variable named isHoldWeapon. This indicates the gun state of the 3D character. Determine if it is not equal to the gun state of this 3D character. Set the character's gun state to this 3D character's gun state. Make a judgment. If true, call the skeletal mesh's play animation function. Set the animation to rev stand idle. Check loop. If false, call the skeletal mesh play animation function. Set the animation to normal stand idle. Run the game. Open inventory UI. The character is not currently armed, so the character plays the normal animation in the inventory UI. Close the inventory UI. Pick up a weapon. Open the inventory UI. The current character is armed, so the character in the inventory UI plays the rev animation. Add comment. Compile and save. Next, make the update weapon function. Add the function named update weapon. Open my character's update weapon display function. Copy all the contents. Paste it in. Remove the judgment that the site is on. Remove judgment socket. Set my player state. Call spawn actor function. Get ID by weapon site. Promote the generate object to a variable named holdWeapon. Set SN to 3D capture weapon hand. Get my game instance and get the name of the stand socket. Set. Set my player state. Promote whether the backpack variable is equipped to a local variable. Set my player state. Call spawn actor function. Get ID by weapon object site. Set SN to 3D capture weapon 1. Set my game instance. Promote the created weapon object to a variable named left weapon. Set the created weapon object to the attach function. Update the right weapon on the back to be the same as the left. Delete the previous one. Copy and paste. Get the weapon 2 object. Set SN to 3D capture weapon 2. Promote the object to a variable and name it right weapon. Get the name of the socket on the right side of the back when there is a backpack. Get the name of the socket on the right side of the back when there is no backpack. Compile and save. Next, listen for weapon change events. Open event graph. Bound the weapon change event. Add a custom event named event weapon changed. Call the update weapon function once on actor creation to update the weapon. unbound the weapon update event on distraction. Compile and save. Finally, a function to clear the weapon needs to be made. Add the function and name it clear weapons. Open the clear equipment function and copy all the content. Paste it into the clear weapons function. Set the first object to the handheld weapon object. Set the second object to the left weapon object. Set the third object to the right weapon object. Open event graph. Call the clear weapon function on distraction. Open the update weapon function. Call the clear weapon function once at the beginning. Run the game. Pick up the weapon. Open the inventory UI, and you can see that the 3D character weapon's status in the inventory UI has been synchronized with the character status. Press X to take back the weapon, and the inventory UI will also synchronize the status. Next, create the update weapon accessory function. Add a function named update accessories. Add an input parameter named character weapon of type item base. This represents the weapon object stored in player state. Add input parameter named 3D weapon of type item base. Indicates the weapon object used in the inventory UI. Convert 3D weapon to item weapon. Convert character weapon to item weapon. Call the update site function for the 3D character weapon object. Call the update muzzle function. Call the update free grip function. Call the update magazines function. Call the busdog function. Get the corresponding object from the character weapon object and set it. You need to determine that both the character weapon object and the 3D weapon object are valid before updating. Compile and save. Open the update weapon function. Call the update accessory function after creating the handheld weapon object. Set the newly created weapon object. Call the update accessories function after creating the left weapon object. Copy and paste. Call the update accessories function after creating the right weapon object. Copy and paste. Compile and save. Next, listen for weapon accessory change events. Open event graph. Bound the weapon accessory change event. Add a custom event named event weapon ACC changed. unbound the weapon ACC changed event on distraction. Call the update weapon accessory function. Character weapon object set to handheld weapon. Get the handheld weapon object and set it. Call the update weapon accessory function. The character weapon object is set to the left weapon. Get the left weapon object and set it. Call the update weapon accessory function. The character weapon object is set to the right weapon. Get the right weapon object and set it. Compile, save. Run the game. Pick up the M4 weapon. Press 1 to equip the sight. Open the inventory UI. 3D character is displayed correctly. Press 2 to change the sight. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. From this lesson, we are creating a drag and drop function for the inventory UI. When you drag and drop an item, a new icon box is created to follow the mouse movement. Let's start by creating this drag and drop box. Create a widget in the inventory folder named iDraggedItem. Open it. Set the screen option to desired. Add a size box component. Check the size to content. Check the override width and set it to 60. Check the override height and set it to 60. Drag in an overlay component. Drag in an image component. Name it BG and uncheck the variable. This is used to display the background color. Set the size to 60. Set the transparency to 0.1. Add an image component named dotted line. Uncheck the variable. This is used to display a dashed border image. Set the image to icon dotted line. Add an image component named icon used to display item icon. Set an item icon. The size is set to 60. The interface is complete. Compile and save. Open graph. Add a function named setIcon. Add input parameter named texture. Tap texture 2D object reference. Get the icon component and call the setTexture function. setTexture. Compile, save. When dragging an item, you need to pass some data along so that we can operate on the dragged item at the end of the drag. Dedicated objects are provided in the Unreal Engine. Create a blueprint in the inventory folder. Enter drag-drop operation. Create a subclass of drag-drop operation named iDraggOperation. Open it. Add a variable named draggedItem of type itemBase and the item object being dragged. Add variable named location of type eInventoryLocation. Indicates the location of the dragged item before it was dragged. Check enabled and spawn. Only these two pieces of information. Compile and save. Open the inventory location enumeration file. Add the locations in full. Add named vicinity list to indicate that it is in the ground item list. Add named backpack list to indicate that it is in the backpack list. Add named weapon to indicate that it is in the weapons bar. Add named weapon ACC to indicate it is in the weapons accessory bar. Save. Look at how the drag and drop function is implemented. Open a widget. There are 3 functions in total for the drag and drop function. Click on the override button and select the onDragDetected function. This function is used to detect dragging and will be executed when a dragging behavior is detected. We can create the drag icon in this function and display it on the screen. The create drag drop operation node can be called in this function, and the drag option blueprint we created earlier can be selected. This will create a drop and drop operation. Pivot is an indication of where the dragged out widget is displayed on the mouse. By default, center will be placed right in the center of the mouse. Default drag visual is the widget that will be displayed when dragging and dropping. Here, the dragged item we created will be selected. Click the override button and select the onMouse button down function. This function will be executed when the mouse is pressed on this widget. In this function, we can determine which button is clicked and thus control which button is allowed to start dragging when the left button is clicked, and which is not allowed to drag when the right button is clicked. The detect drag if pressed node can be called in this function to inform the dragging system that it is pressed and ready to start dragging. Pointer event is the pointer event, and drag key is the specific key provided for the pointer event. If the specified key is pressed, a detect drag response will be issued. Click on the override button and select the onDrop function. This function is executed when the mouse drags an object to drop in this widget. In this function, the logic for the item transfer is executed. With these three functions, we can implement the drag and drop functionality. These three functions will be used later in the creation process. Delete the three functions you have just created. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are creating a function to switch items between the ground and the backpack. Both ground and backpack items are displayed using the goods item widget, so it is necessary to determine where the current goods item belongs. Open the goods item widget. Add a variable named location of type E inventory location. Open the siteContent function. Add an input parameter named location of type E inventory location. Promote location to the variable. Compile, save. Open the vicinity list widget. When setting item information, set location to vicinity list. Compile, save. Open the backpack list widget. When setting item information, set the location to the backpack list. Compile and save. Next, create the item drag and drop related functions. Open the goods item widget. Override the onMouse button down function. Call the detect drag if pressed node to notify the dragging system that it is pressed and ready to start dragging. Set the pointer event to set the drag button to be the left mouse button. Override the onDragDetected function. Add the create drag drop operation node. Set class to addDrag operation. Set item base to dragged item. Set location to location. Set the return value. Then generate a drag and drop box. Add the create widget node. Set class to addDragged item. Call the setIcon function. Get the icon for the current item. Get the brush, expand it, and keep the image. Convert to Texture 2D. Set to Texture. Compile, save. Set the created widget to drag, drop, default display. Open on-mouse button down function. Connect the return value. Compile, save. Run the game. Pick up some items. Open the inventory UI. Drag and drop items. You can see that both the vicinity and backpack list can generate drag objects using left mouse button dragging. Next, create the received drag and drop function. Open the vicinity list widget. Override the onDrop function. Convert operation to iDrag operation. Get the drag object promoted to a local variable. Name it DragItItem. Get the location, switch. If drag it from a backpack, it throws the item. Call the DragItItem function in my player controller. Set DragItItem to item. Return true, which does not mean that the item was dropped successfully, but indicates that the dragging action is over. Compile, save. Open the backpack list widget. Set the location to backpack list. Compile, save. Run the game. Pick up some items first. Open the inventory UI. Drag the items from the backpack list to the vicinity list. You can see that the inventory UI is displayed correctly, and the thrown items has been created on the ground. Next, make the backpack list to receive the drag and drop function. Override the onDrop function. Copy the contents of the onDrop function from the vicinity list. Get DragItItem promote to a local variable. Delete the dropped item. Get dragged item. Get item tab, switch. Connect vicinity list. Get player controller. Convert to my player controller. Call the pickup_item function. Performs pickup of items when the item tab is weapon accessory, bullet, health, burst. Other items cannot be placed in the backpack. Get the dragged item, convert it to pickup base, and set it to item. Determine if the pickup was successful. If the drag item is successfully obtained, call the distree function. Returns true. Connect to operation. Compile, save. Run the game. Open the inventory UI. Drag items from the vicinity list to the backpack list. You can see That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making functions to switch between the ground and the equipment box for equipment and fashion. Let's start by making the equipment box receive drag and drop function. Open the equipment widget. Override the onDrop function. Open the backpack list widget and copy the contents of the onDrop function into the equipment widget. Connect the operation. Promote DragItItem to a local variable. Remove the picked item function. Call the pickup equipment function. Connect helmet, vest, and backpack. Set the item object. Compile, save. Run the game. Open the inventory UI. Drag the equipment to the equipment box. You can see that the inventory UI is displayed correctly, and the picked up items on the ground are displayed. Here, the equipment will be correctly equipped, no matter which equipment box you drag it onto. Next, make the Fashion tab. Adjust the node position. If it is a fashion, call the pickup fashion function. Set the item. The fashion must be picked up successfully, so perform the destruction directly after the pickup is complete. Compile and save. Run the game. Open the inventory UI. Drag the fashion to the equipment box. You can see that the inventory UI is displayed correctly, and the picked up items on the ground are displayed. Override the onMouse button down function. Get the item object and determine if it is valid. If valid, call the detect drag if pressed node to inform the dragging system that it is pressed and ready to start dragging. The pointer event. Set the drag button to be the left mouse button. Override the onDrag detected function. Open the goods item widget. Copy everything from the onDrag detected function. Compile, save. Open the onDrop function of the vicinity list widget. Copy and paste the object. Call the drop detected function. Set the object. Select the check, which determines if the backpack has enough capacity after dropping it. When it is dropped, connect the return. Run the game. Open the inventory UI. Drag the equipment to the equipment box. Drag the equipment to the vicinity list. You can see that the inventory UI is displayed correctly, and the equipment that was thrown to the ground is created on the ground. Then, make the throw fashion function. Copy the object. Call the throw fashion function. Set the object. Connect the top, bottom, and shoes. Connect the return. Run the game. Open the inventory UI. Drag the fashion to the equipment box. Drag the fashion to the vicinity list. You can see that the inventory UI is displayed correctly, and the fashion that was dropped on the ground is generated. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make functions to switch weapons between the ground and the weapon box. Let's start by making the weapon item widget to receive the drop function. Open the weapon item widget. Override the onDrop function. Open the equipment item widget and copy the contents of the onDrop function into the equipment widget. Promote target item to a local variable. Remove the pickup equipment function. Remove the pickup fashion function. Call the pickup-weapon function. Connecting weapon tabs. Converts dragged item to a weapon pickup object, set. Select the location. Add select node. Set location to index. Add pin. If location is 1, set the location to the left. If location is 2, set the location to the right. Set to location variable. Set is assigned to true. Compile. Set operation. Compile, save, run the game. Open the inventory UI. Drag the weapon to the weapon box. You can see that the inventory UI is displayed correctly, and the weapon that was picked up on the ground is destroyed. The location of the weapon on the character is also displayed corresponding to the dragged location. The replacement weapon is also correct. Override the on-mouse button down function. Get the weapon object and determines if it is valid. If valid, call detect drag if pressed node. Set the pointer event. Set the drag button to be the left mouse button. Override the onDrag detected function. Open the equipment item widget. Copy everything from the onDrag detected function. Remove icon related nodes. Get the weapon object, get the data. Expand it and keep the icon. Setup. Set the weapon object to dragged item. Set the position to weapon. Compile, save. Open the onDrop function of the vicinity list widget. Copy and paste the object. Connecting weapon tab. Call the drop weapon function. Convert dragged item to weapon item object. Connect return. Run the game. Open the inventory UI. Drag a weapon to the weapon box. Drag the weapon to the vicinity list. You can see that the inventory UI is displayed correctly and that the weapon that was dropped. For this lesson, thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making functions to switch weapon accessory between the ground or backpack and the accessory box on the weapon box. Let's start by making the weapon accessory item widget to receive the drop function. Open the weapon accessory widget. Override the onDrop function. Open the equipment item widget and copy the contents of the onDrop function to the equipment box widget. Promote dragged item to a local variable. Remove the switch item tab. Remove the pickup equipment and pickup fashion functions. Get dragged item object. Get item tab and determine if it is a weapon accessory. call the equip weapon accessory function. Set target item. Check that it is from the ground. Set owner to weapon. Add judgment. Connect backpack tab. Call the equip accessory function. Set variables. Determine if it succeeds. Uncheck it from the ground. If successful, performs destruction of the object. If it fails, return directly. Compile, save. Run the game. Open the inventory UI. Equip weapons. Equip the weapon accessories. You can see that the inventory UI is displayed correctly, and the weapon that was picked up on the ground is destroyed. The warning weapon accessory cannot be equipped. The replacement weapon accessory is also correct. Override on mouse button down function. Get the accessory object and determines if it is valid. If valid, call detect drag if pressed node. Set the pointer event. Set the drag button to be the left mouse button. Override the undrag detected function. Open the equip item widget. Copy everything from the undrag detected function. Set the weapon accessory object to the dragged item. Set the location to weapon accessories. Compile, save. Open the drag and drop operation object. Add variable named ACC owner and type item weapon. Check the edit table and spawn. When dragging and dropping a weapon accessory, you need to know the weapon object the weapon accessory belongs to. Compile, save. Open the accessory item widget. Re-add the create drag drop operation node. Set class to add drag operation. Set the accessory object. Set location to weapon accessory. Set owner to ACC owner. Set default display. Compile, save. Open the undrop function of the vicinity list widget. Copy and paste the object. Call the remove weapon accessory function. Set the drag and drop object. Check yes to ground. Get operation. Convert to drag operation. Get the object to which the accessory belongs. Set. Connect, return. Compile, save. Run the game. Pick up the weapon and equip the corresponding accessory. Drag the accessory to the vicinity list. The inventory UI is displayed correctly, and the remove weapon accessory is generated on the ground. Replacements are also fine. Open the undrop function of the backpack list widget. Copy and paste the switch. Copy and paste the object. Replace the player controller object. uncheck is ground. Connect accessories. Connect weapon accessories. Return. Compile. Save. Run the game. Pick up the weapon and equip it with the corresponding accessory. Drag the accessory to the back. Hello everyone, I'm Big Cat. Starting from this lesson, we make the UI related to the main interface. In this lesson, we make the crosshairs UI. Create a folder in the UI folder and name it main UI. All main UI related UI is put into this folder. Create a widget named crosshairs UI. The screen zoom is set to full screen. Set the size to 19201080. Drag in an overlay component. Name it dot. And select its variable. Select the center for the anchor point. The XY position is 0. Alignment is set to 0.5, 0.5. Check the size to content. Drag in an image component and uncheck the variable. Set the image size to 4:2. Set the horizontal alignment to center. Set the color value to A9, A6, A5. Copy the image component. Set the size to 2:4. Set the vertical alignment to center. Drag in an image component and name it cross left. Set the anchor point to the center. Clear the XY position. Check the size to content. Set the size to 62. Set the color value to A7, A7, A2. And the transparency to 0.9. Set the alignment to 0.5. Duplicate the component and name it crosstop. Set the size to 260. Set the alignment to 0.51. Duplicate the component and name it cross-right. Set the X position to 10 and the Y position to 0. Duplicate the component and name it cross-down. Set the alignment to 0.50. Check cross-right. Set the X position to 0 and the alignment X value to 0. Compile and save. Next, display the UI to the screen. Open my HUD. Add the sequence node. Create the crosshairs UI and add it to the screen. Compile, save, run the game. The crosshairs are now displayed on the screen. Go back to crosshairs UI and open graph. After the UI has been created, get the player character. Get the player controller. Get the player state. Add a sequence node after the event tick. Get whether the player is currently running by pressing Run via my player controller. Get whether the player is currently free-falling in the air via my character. Get whether the parachute is currently open in the air via my character. Add an OR node. Determine if one of these is true, then all crosshairs need to be hidden. Get the dot component called the setVisibility function and set it to hidden. Get all crosshairs components and set them together. If no wrong key is pressed, show the center point first. Get whether or not the wrong is currently held via my character. If yes, show all crosshairs components. Then you need to determine if the sight is currently on. If the sight is on, you need to hide all the crosshairs. Copy and paste. Get the sight on with my character. Add the select node. Set the set on state to index. Show if the sight is not on, hide if it is on. Set. Head cross component if on-gone is currently held. Add comment. Next, make the crosshairs zoom function. Currently, there are 4 states of the sight: non-aimed still, non-aimed moving, aimed still, aimed moving. The schooling effect is achieved by changing the position of the cross component. Add a function named updateCross. This is used to update the position of the cross component. Add input parameter named leftX. Type float indicates the x value of the left cross component. Add input parameter named rightX indicates the x value of the right cross component. Add input parameter named top y indicates the y value of the top cross component. Add an input parameter named down y indicates the y value of the lower cross component. Get cross left and call the set translation function. Set left x to the x value. Get cross right and call the set translation function. Set right x to the x value. Get cross top and call the set translation function. Set top y to the y value. Get cross down and call the set translation function. Set down y to the y value. Compile, save, go back to event graph. Next, make the scaling logic. First, get the handheld weapon object. If there is a handheld weapon, first determine if it is currently moving. Get the forward access value and the right access value from the player controller. Determine if both values are equal to 0. If true, then the character is still. Get the aiming state via my character and determine if it is aiming, then it is aiming at the still state. Call the update cross function. Get the handheld weapon object. Get weapon data. Expand. Keep all still data for cross offset. Set aim still min to left X and up Y. Set aim still max to right X and down Y. If not aiming, it is non-aiming still. Call the update cross function. Set the still min to the left X and upper Y. Set the still max to the right X and lower Y. If in a moving state, again need to determine if aiming. Copy. And paste. Add comment. Compile, save, run the game. There is no gun state, only a center point. Pick up the weapon. Crosshairs are displayed. Move and the cross offset becomes larger. Press to aim. Move. You can see that the crosshairs offset is different for each of these states. Turning on the sight has all the crosshairs components. Running also hides all crosshairs components. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make an Action Tips UI. Create a widget in the main UI folder named Action Tips UI. Open it. Set the size to 19201080. Add a horizontal box. Set the anchor point to be the center point. Set the X position to 110 and set the Y position to 120. Select the set to content. Open the weapon item widget. Copy the location border into the horizontal box. Rename the border name to border. Change the text name to input and uncheck the variable. Set the font tab to bold. Set the color to EF. Drag a border component into the horizontal box. Use this border as the background image for the text. Set the border distance from the left to 2. Set the border to be centered horizontally and vertically. Set the distance to the left to 8. Set the distance to the right to 8. Set the color to 0000000 and the transparency to 0.2. Drag in a text component, name it info, and select it as a variable. Set the color to EF. Set the font to A, the tab to medium, and the font size to 70. Set the shadow color to 0.5 for transparency. Setting the text to different lengths, we found that the background will follow the length of the content. We have taken advantage of the fact that the border will follow the content to create a background that will stretch according to the content. Set the text to F. Compile and save. Open graph. Add a function named setInfo. Add an input parameter named info of type text. Get the info component and call the setText function. Set. Compile, save. Next, display the Action Tips UI to the screen. Open my HUD. Add the Create Widget node and select Action Tips UI. Promote it to a variable and name it Action Tips UI. Call the setVisibility function and set it to hidden. Add to the screen. Add function named ShowActionTipsUI. Call this function to show the Action Tips UI. Add input parameter named info of type text. Get the Action Tips UI object and call the setInfo function. SetInfo. Get the Action Tips UI object and call the setVisibility function. Set to show. Add function named HidActionTipsUI. Call this function to hide the Action Tips UI. Get the Action Tips UI object and call the setVisibility function. Set to head. Compile and save. Next, show the Action Tips UI when picking up items. Open the targeting item function of my player controller. Find the place where the highlight is displayed. Get the HUD object and convert it to my HUD. Call the ShowActionTipsUI function. Get the highlighted item object. Get UI display prefix variable. Get the name variable. Convert both variables to string type. Call the append function to splice the two texts together. Set to info. Add comment. Hide the Action Tips UI before looping through the array. Get the HUD object and convert it to my HUD. Call the head Action Tips UI function. Add comment. Compile and save. Run the game. As you can see, the Action Tips UI is That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make the message tips UI. Create a widget in the main UI folder named message tips UI. Open it. Set the size to 19201080. Drag in a text component. Name it info, and check its variable. Select the anchor point down the middle. Set x to 0 and y to -220. Alignment is set to 0.5, 0.5. Check the size to content. Set the default display to not enough space. Set the color value to D9, D9, D9. Set the font to A, the font type to medium, and the font size to 20. Set the shadow transparency to 0.5. Compile and save. Next, give the text a fading animation. Open the animation panel in the Window tab and the timeline panel. Add an animation named Height Animation. In the timeline panel, click on and track and select the color and transparency. Put the timeline to the 4-second mark and add a keyframe. Set the transparency to 0. The text will appear normal for the first 2 seconds and will start to fade out at the 2 seconds until it disappears completely at 4 seconds. In the info track, click on Add Track and select the shadow color. Create keyframes at 0, 2, and 4 seconds, respectively. Set the transparency to 0 for the 4-second keyframe. Set the transparency to 0.5 at 2 and 0 seconds. Drag the timeline to see the animation effect. Compile and save. Open graph. Add a function named setInfo. Add input parameter named info, type text. Get the info component and call the setText function. Set. Call the setVisibility function. Set the current widget to be visible. Get the hidden animation object. Call the playAnimation function. Add a variable named checkAnimation. This is used to indicate whether or not to check that the animation has finished playing. Set the checkAnimation variable to true. Compile and save. Hit the current widget when the animation has finished playing. Check if the animation has finished playing in the tick event. Determine if the animation needs to be checked. Get the hidden animation object and call the whether or not it is playing function. Determine. If it is not playing, set the checkAnimation variable to false. Call the setVisibility function to set to hidden. Compile, save. Open my HUD. Add Create Widget node and select Message Tips UI. Promote to a variable named Message Tips UI. Head by default, call the setVisibility function and set it to hidden. Add to the viewport. Set order to 1 so that this UI will be displayed above other UIs with order 0. Add function named showMessageTipsUI. Add input parameter named info of type text. Get the message tips UI object and call the setInfo function. SetInfo. Get the message tips UI object and call the setVisibility function. Set to show. Compile and save. Next, call this function where you need to prompt for information. Open the event graph function of my player controller. Get the HUD where the object reference will created and converted to my HUD. Promote it to a variable and name it HUD. Open the pickup_item function. Call the showMessageTips UI function in my HUD when checking for low backpack capacity. Set info to not enough capacity. Compile, save. Open the pickup equipment function. Call the showInfo UI function in my HUD when checking for a low backpack. Set info to the new backpack not enough capacity. Compile, save. Turn on the discard equipment function. Call the showInfo UI function in my HUD when checking for low backpack capacity. Set info to not enough capacity when discard. Compile, save. Open the equip weapon accessory function. Call the showMessage UI function in my HUD when checking for low backpack capacity. Set info to not enough capacity to replace it. Compile, save. Open the unload weapon accessory function. Call the showMessage UI function in my HUD when checking for low backpack capacity. Set info to not enough capacity. Compile, save. Open the weapon object blueprint. Create HUD reference. Call the showMessage UI function in my HUD when checking for not bullets. Set info to no more bullets. Compile, save. Next, test. Run the game. Pick up the items. You can see the message when the backpack is running low. Pick up a larger backpack. Pick up a full item. Pick up a small backpack at this time. A message will be displayed indicating that the new backpack is low on capacity. Inventory UI. Discard the backpack. The discard fails, prompting that you cannot discard the ground backpack. Fill up the backpack. Unload an accessory from the weapon into the backpack. Failed to unload, prompting not enough backpack capacity. Replace a weapon accessory from the ground onto the weapon. Open the Equip Weapon Accessory function of my player controller. A message box is displayed. Set the test to not enough capacity to replace it. Compile and save. The prompt message UI is created. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we built the user information UI. Create a widget in the main UI folder named User Info UI. Open it. Set the size to 19201080. Add the vertical box component. Anchor is select down and middle. Position X is set to 0 and position Y is set to -100. Alignment is set to 0.50. Check set to content. Drag in an overlay. Set the horizontal and vertical alignment to fill. Drag in a blur background component. Set the horizontal and vertical alignment to fill. Set the blur strength to 4. Drag in an image component. Name it pubg. Set the horizontal and vertical alignment to fill. Set the image size to 450/45. Set the color value to black. Set transparency to 0.3. Drag in the horizontal box. Set the vertical alignment to the middle. Drag in an image component. Name it backpack icon. Set the distance to the left to 10. Set the vertical alignment to the middle. Set the backpack image. Drag in an image component. Name it helmet icon. Set the distance to the left to 10. Set the vertical alignment to the middle. Set the helmet image. Drag in an image component. Name it vest icon. Set the distance to the left to 10. Set the vertical alignment to the middle. Set the helmet image. Drag in a widget switcher. Name it mode switcher. Set the distance to the left to 36. Set horizontal alignment to left. Set vertical alignment to the middle. Drag in an image component. Name it single. And uncheck is variable. Set the image. Drag in an image component. Name it auto. And uncheck is variable. Set the image. Drag in a size box component. Set the distance to the left to 25. Set the width override value to 35. Drag in a text component. Name it mag amount. And select its variable. Set the horizontal alignment to right. Vertical alignment is set to medium. Text is set to 30. The color is set to E7, E7, E7. The font is set to B. Font type is set to BNT. Font size is set to 30. The outline size is set to 1. The outline color is set to 2F, 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 7F. Duplicate. Set distance left to 10. Select the text. Name it backpack amount. Set the distance from the top to 6. Align horizontally to the left. Align vertically to the top. The text is 110. Set color to 919191FF. The font size is 24. Next, create the energy bar. Drag in an overlay. Name it energy bar and select its variable. Set the distance from the top to 1. Drag in a horizontal box. Name it BG box. Drag in an image component. Uncheck its variable. Set the size to 84. Set the color to 00000004C. Duplicate. Set the distance from the left to 5. Set the size to 160. Duplicate. Set the size to 120. Duplicate. Set the size to 40. Duplicate. Name is value box. Select the first image. Name it energy bar 1. Check its variable. Set the tuning to horizontal. Set the color to DEA 309FF. Select the second image. Name it energy bar 2. Check its variable. Set tuning to horizontal. Set the color to DEA 309FF. Select the third image, named energy bar 3, and check its variable. Set tuning to horizontal. Set the color to DEA 309FF. Select the fourth image, named energy bar 4, and check its variable. Set tuning to horizontal. Set the color to DEA 309FF. Next, make a health point bar. Drag in an overlay and name it health bar. Set the distance from the top to 1. Drag in a background blur component. Set the horizontal and vertical alignment to fill. Set the blur strength to 4. Drag in an image component. Name it BG. And uncheck its variable. Set the size to 450, 22. Set the color to 0000004C. Drag in the image component. Name it health value. And uncheck its variable. Set the distance from the top to 1. Set the size to 450/20. Set the color to BC, BD, BD, FF. Set pivot to 0, 0.5. Compile and save. Open my HUD. Create a user info UI. Promote to variable and name it user info UI. User info UI is displayed correctly. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make the logic part of the user info UI. Open the graph of user info UI. First, make the synchronized equipment display. Get a reference to my player controller. Get a reference to my player state. Add the sequence node to the tick. Get the backpack icon. Call the setTexture function. Set texture to backpack level 0. Get the helmet icon. Call the setTexture function. Set texture to helmet level 0. Get the vest icon. Call the setTexture function. Set texture to vest level 0. Get all current equipment via player state. Loop. Get the item tab. Switch item tab. If helmet, copy set helmet texture. If it is a backpack, copy and set the backpack texture. Cast to equipment object. Get datas. Break. Set to texture. Add comment. Next, synchronize the weapon mode display. Get the currently hold weapon object from player state. Determine if it is valid. Get the mod switcher. If it is valid, set it to visible. If invalid, set to hidden. If visible, get the mod switcher. Call the active widget index function. Get the firing mode by weapon. Add select node. Set index. If single, the value is 0. If auto, the value is 1. Set index. Add comment. The next step is to create a single nest bullet content display. Get the currently hold weapon object from player state. Determine if it is valid. Get mag amount and backpack amount. If valid, set to show. If invalid, set to hidden. If shown, get the mag amount. Call the setText function. Get the currently hold weapon object via player state. Get the number of bullets. Set to text. Get the current total number of bullets function via player state. Get data by weapon object. Break. Set the bullet ID. Get backpack amount. Call the setText function. Set text. Add comment. The next step is to create a single nest energy point display. Get the current energy point from player state. Determine if it is greater than 0. Get the energy bar. If the value is greater than 0, then set it to display. If not, set to collapsed. Get energy bar 1. Call the setRenderScale function. Call the clamp node. The value is set to the current energy value. The minimum is set to 0 and the maximum to 20. Divide by 20. Set to scale X. Copy, paste. Get energy bar 2. Min set to 20, max set to 60. Subtract 20. Divide by 40. Copy and paste. Get energy bar 3. The minimum value is set to 60. The maximum value is set to 90. Subtract 60, divide by 30. Copy and paste. Get energy bar 4. The minimum value is set to 90. The maximum value is set to 100. Subtract 90, divide by 10. Add comment. Compile and save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make functions related to the health value bar display for the character information UI. Set health value to be the variable. Open graph. Get the health value and call the setRenderScale function. Control the display of the health bar by adjusting the scaling of the x-axis. Get the current health value from player state. Divide it by 100. Set the scaling value to the x-axis. Open the designer. Next, create an animation effect when the health value falls below 20%. Open the Animations panel and the Timeline panel. Add an animation named Health Animation. Add a track and select the health value. Add another track and select the color and opacity. Add the key as a 0 second. Set R to 0.909804. G to 0.016468 and B to 0. Add the key for A at the 1 second point. Set A value to 0.1. Add key at 2 seconds. A value of 1. Open graph. Next, make the animation logic that plays when health is low. Determine if the current health percentage is less than 20%. Get the health animation object and determine if the animation is currently playing. Call the play animation function from the health animation object. If no animation is currently playing, then start the animation. Get the health animation object and call the stop playing animation function. Called if the current health value is greater than 20%. Get the health value object and call the set color and opacity functions. Make color. Set R to 0.737255, G to 0.741176, B to 0.741176, and A to 1.0. Add a comment. Add a comment. Compile and save. Next, test the user info UI. Run the game. Pick up the backpack. displayed correctly. Pick up the helmet, displayed correctly. Pick up vest, displayed correctly. Pick up weapon. It shows one round, which is incorrect. Open graph. Find the synchronized bullet display. Here we should get the number of bullets, not the number of weapons. Run the game. Pick up the weapon and the display is correct. Pick up bullets, displayed correctly. Change magazines, displayed correctly. The current health bar is not displayed correctly. Score Y should be set to 1. Run the game. The health bar is displayed correctly. Open my player state. Set the default health value to 90. Run the game. The health value animation is displayed correctly. Set the default health value to 100. Compile and save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make a countdown UI. Create widget in the main UI folder named countdown UI. Open it. Set the size to 19201080. Add a vertical box. Anchors is set to center. Position X is set to 0 and position Y is set to 80. Alignment is set to 0.50. Cheek set to content. Add a text. Set horizontal alignment to center. Set the text to battle starts in. Set the color value to 0.94902. Set the font to A. Set the tab to medium. Size is 27. Set outline size to 1. Set transparency to 0.1. Add image. On-cheek is variable. Set horizontal alignment to center. Set image to len 1. Add text. Name it time label. Cheek is variable. Set horizontal alignment to center. Set text to file. Set the color value. Set font to B. Set font tab to BNT. Set size to 60. Set outline size to 1. Set A to 0.1. Compile, save. Open graph. Add a variable named time. Type integer. Set the default value to 5. This means 5 seconds. Get time label. Call the setText function. Get the time variable set. Get the time variable. Determine if it is greater than 0. If greater than 0, delay by 1 second. Time value minus 1. Loop. If the time value is already 0, call the remove from parent function. Compile, save. Open my HUD. Display the countdown UI. Run the game. The UI will be automatically deleted after 5 seconds. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we built the interface for the Direction UI. Create a widget in the main UI folder named Direction UI. Open it. Set the size to 19201080. Add an overlay component. Set anchors to top, center. The position is set to 020. Size is set to 758. Alignment is set to 0.50. Add a retain box component. Cancel is a variable. We use this component is control the actual display area of the image. Create a mask. Name it mMask. Set it to user interface. Set it to translucent. Add a texture sample. Convert to a parameter and name it texture. Select texture as default texture. Add a texture sample. Set texture to mask. Multiply. Set to final color and opacity. Apply, save. Go back to the Direction UI. Set the effect material to mMask. Add a canvas. Add an image. Name it BG. Cancel is the variable used to display the background image. Set anchors to top, center. Position is set to 00. Set alignment to 0.50. Check the size to content. Set image to direction BG. Add an image. Name it Word image. Used to display a ruler image. Set anchors to center. Position is set to 00. Size is set to 307558. Alignment is set to 0.5. Set image to direction word. Image size set to 102558. Tiling is set to horizontal. Add an image. Name it triangle. Cancel is the variable used to display the triangle icon. Distance to the left is 1. Distance to the top is 5. Horizontal alignment is set to center. Image is set to direction triangle. Add a size box. This is used to store the number of the current direction. Horizontal alignment is set to center. Vertical alignment is set to down. The width is set to 25. Height is set to 25. Add a blur background. Horizontal alignment is set to center. Vertical alignment is set to down. Distance to the top is -3. Blur strength is set to 10. Add a text. Name it current direction. Checked is the variable used to display text in the current direction. Text is set to 75. Set the color value. The font is set to A. Font type is set to bold. Font size set to 17. Outline size set to 1. Outline transparency is set to 0.3. Set the text to be aligned with the margins as centered. Compile and save. Open my HUD. Show the direction UI. Compile and save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we create the logic function for the direction UI. Select the word image component. If you connect the head and tail of this picture to form a circle, it will be exactly a complete southeast northwest. Go to graph. What we are doing is moving the position of the word image component according to the current angle of rotation of the character. Get the canvas slot object for the word image component. Promote it to a variable and name it word image slot. We will perform position operations on this slot later. Add a comment. Next, we need to know the x value of the image that needs to be moved when the character is rotated by 1 degree. Get the select brush of the word image. Expand the image size. This image size is the unit in slit. One rotation is a total of 360 degrees. Use the length of the slit and divide by 360. This value is the x value that needs to be moved for a rotation of 1 degree. Promote it to a variable named x to 1 degree. Add a comment. Next, we use event tick to update the display of the direction in real time. Get the word image slot and call the set position function. Open the scenes. First, we set the time of the scenes to morning, so the current direction of the sun is east. Then, the direction facing the blue house is north. Get the rotation value of the current character. Use the delta node to normalize this rotation value. The B values as 270, 270, 270. Expand return value. Add print. Print the Z value. Run the game. When the character is facing the blue house, the Z value is 0, correct. Delete the print. Next, we need to calculate the position x of the word image. Use the normalized Z value multiplied by x to 1 degree to get the position x value for the current angle. Use this value to create a vector 2D. Set this vector 2D to the set position function. Run the game. when the character is facing due north, the orientation UI is displayed correctly. The southeast northwest display is now all correct. Add a comment. Add a comment. Next, set the display of the labels. Add the sequence node after the event tick. Since we need to display integer value on the label, round the values first, call the round node. The current value is from -180 to 180. We don't want to display a minus number. We want to display from 0 to 360. Determine if the value is greater than or equal to 0. If it is greater than or equal to 0, promote it to a variable, name it current degree. If it is less than 0, you need to add 360. Then, set this value to current degree. On the level, we only show numbers that are divisible by 5. To determine if the remainder of current degree divided by 5 is equal to 0. Create a variable called labelText of type text. Convert current degree to a string type. Use switch to determine the string value. Thread pin names in details. There are 8 directions in total that need to be displayed using letters. So, create 8 elements here. Set them to 0, 45, 90, 135, 180, 225, 260, and 350. At 0 degrees, it is due north. Set label text to N. At 45 degrees, it is northeast. Set label text to NE. At 90 degrees, it is due east. Set label text to E. At 135 degrees, it is southeast. Set label text to SE. At 180 degrees, it is due south. Set label text to S. At 225 degrees, it is southwest. Set label text to SW. At 270 degrees, it is due west. Set label text to W. At 350 degrees, it is northwest. Set label text to NW. If neither is the case, the number is displayed. Add the sequence node before switch. Get current direction and call the setTest function. The value is label text. Add comment. Compile, save. Run the game. The display is correct. That is this lesson. Thank you for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. Starting with this lesson, we make use of the atom function. Currently, there are 2 types of atom that can be used. One is health, which increases health value directly after use. The other type is energy atoms, which gain energy when used. Energy can be converted to health after a certain amount of time. This lesson starts by creating the progress bar UI that is displayed on the inventory UI when an item is used. An item will have a progress bar on the item when it is used. Open the Goods Items Designer and add an image component named Use Item Mask. This is used to display the progress bar. Check the size to content. Set the size to 225/62. Set the color value to 090909. A is 0.6. Set the x-axis pivot point and the default x-axis scrolling to 0. Compile and save. An animation will play when the program bar finishes. Open the Animations panel and add an animation named Use Item Animation. Add an animation to the Use Item Mask component. Add color and transparency animations. At 0.75 seconds, add the key. Set the value to 0. Next, make the progress bar logic. Open graph. Add the variable named needTime tab float. This indicates the total amount of time it will take to use the item. Add a variable named time. This indicates how long it has taken to use the item. Determine if the time needed is greater than 0. Use the time plus the delta value. Add the clamp node. Set the value. The minimum value is 0 and the maximum value is the total time needed. Set to time. Get Use Item Mask. Divide the direction by the time needed. Set to score X value. Set the score Y value to 1. Determine if the direction and the needed time are equal. Call Use Item Animation. Call the Play Animation function. Set both the time needed and the direction to 0. Next, create the mouse right-click logic. Get the Effecting button. Determine if it is the right mouse. Determine if location is a backpack list. Get the item tab from item base. Determine if it is a health or a burst. Add branch. Add comment. Get atom tab from atom base. Switch atom tab. Get atom base. Switch to health. Get datas. Set need time to need time. Connect health. Convert to burst. Get datas. Set the time needed to need time. Connect the burst. Add comment. If not use the atom, start drag and drop. Add a comment. After starting to use the atom, you should disable all actions in the inventory UI. For example, do not show the mouse slide or light up. The function will be made later in the cross. Run the game. Use the atom. The program bar is displayed correctly. If you close the inventory UI when you have not finished using an atom and open it again, the progress bar does not continue to be displayed, a function that will be created later in the lesson. Next, make the stop animation play function. Add the function named stop use. Get the use atom mask. Call the set score function. Set the score y value to 1. Set need time and time to both 0. Compile and save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. When using an atom, a circular progress bar is displayed on the main UI. The circular progress bar requires us to create a material. This lesson will be about creating this material. Create a material in the UI, main UI folder named MUseAtomBar. Open it. Since this material is prepared for use in the UI, change the material domain to user interface. Change the blend mode to masked. Create a vector tab parameter. Name it color. The default value is set to white. This color is the final color of the material, so connect this color to the final color. Next, we need to make a circle. Create a radial gradient exponential node. The purpose of this node is to create a radioactive gradient from the input UV coordinates. Press the 1 key and then press the left mouse button to create a value and set the value to 5000. Connect the value to the density input parameter. Create a value and set the value to 0.5. Connect the value to the radius input parameter. Duplicate and set the radius to 0.45. Create a subtract node and subtract the circle with the larger radius from the circle with the smaller radius. Click on the small triangle in the top right corner of the node, and you can see that a circle is obtained by subtracting two circles. Add a vector to radial value node. The purpose of this node is to convert vector 2 to an angle. or to convert UV coordinate data to radio coordinates. Create a texture coordinate. We want to get a texture coordinate minus 0.5. Then we want to multiply. Create a multiply. Add vector 2D and set the value to 2 minus 2. Connect multiply. We will explain later in a visual way what this vector does. Connect the V2 parameter. Add a value to convert it to angle. Add a scalar parameter named % to set the percentage of the current circular progress bar. Set the default value to 0.1. Connect to the add node. Take the return value of add floor and see the effect showing 10% of the entire square. Multiply the flow value by the circular ring made earlier to get the 10% of the circle. Connect this value to the opacity mesh node of the material sphere. Next, look at what the vector does. Modify the first value in the vector to -2 and find that it changed the position of the starting point of the circle. Restore the first value to 2, modify the second value to 2, and you can see that the direction of the progress bar's expansion has changed. Set the vector to a value of 2 minus 2. We want this circular progress bar to start at the top and need to do a rotation operation. Add the custom rotator node. The purpose of this node is to rotate, where the input parameter rotation angle is the angle to be rotated. It is a value from 0 to 1, with 1 representing a full rotation. Set the rotation to 0.25. Connection. The starting point of the circular progress bar starts at the top, where we want it to be, and will grow in a clockwise direction. Apply. Save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make a circular progress bar UI. Create a widget in the UI main UI folder named useItemUI. Open it. Set the size to 19201080. Drag in an overlay component. Select the size to content. Drag in an image component. Name it BG, and uncheck the variable. This is used to display the progress bar background image. Set the image to circle BD. Drag in a text component named SEC. Unchecked is the variable used to display the number of seconds. Set the text display to 8.5. Set the font to B, the tab to BNT, and the size to 31. Set the horizontal and vertical alignment to be center. Drag in an image component named progress bar. This is used to display the progress bar. Set the image to useItemBar. Set the horizontal and vertical alignment file. Select the overlay component. Set the anchor in the center. Set the alignment to 0.5. Compile, save. Open graph. Initialize in construct. Get SEC call setText function. Create dynamic material instance. Select useItemBar. promote to variable named bar material ref. Get the progress bar. Call the set material function. Set the material. Call set parameter. The parameter name is set to %. Calculate the current programs in real time in event tick and update the animation display. Add a variable named time, tab float, indicates the total time taken. Add a variable named past time, tab float, indicates the time that has passed. Determine if time is greater than 0. Use past time plus the delta value. Call the clamp node. The maximum value is set to 10. Set to past time. Get SEC. Call set text. Subtract past time from time. Convert to text tab. Set. Get the material object. Call the set parameter value function. The parameter is named %. Divide its time by past time. Set. Determine if the values of past time and time are equal. If they are equal, then progress is complete. Set the values past time and time to 0. Hit save. Add a function, name it start. Add an input parameter, named time, of type float. Set the past time value to 0. Set the time value. Compile, save. Open my HUD. Create UI. Add function named showUseItemUI. Call the start function. Display the UI. Add function named headUseItemUI. Head the show UI. Compile and save. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about creating logic related to using items. Open the event graph of item use space. Get the MyPlayerState object. Create a function named startUse. Add output parameter named time, tab float. Indicate the time needed. Add variable named value of tab float. Indicate the medicine value. Add variable named limit of tab float. Indicates a limit value. Add a variable named canUse of tab boolean. Indicates whether or not it is usable. Add sequence node. Get the item data first. Get item tab. Determine if it is a medicine. Get the data. Select the health table and the burst table. Expand them. Set the use time, value, and limit. Add comment. Get the current player health value. Determine if the value is less than the limit. If true, set can be used. Return use time. If false, return 0. Add comment. Add a function named stopUse. Set not use. Open event graph. Next, time check. Determine if it is usable. If usable, subtract the data value from use time and set it to use time. Determine if it is less than or equal to 0. If true, set unusable. Determine if it is currently health. Add the current health value with value. Clamp. Set the maximum value to limit. Call the setHealthValue function. Set value. Copy and paste. Get the energy value. Energy value function. Set value. Add a comment. Open the player controller. Next, make the logic for triggering the use of items. Add the function named item used. Category is items used. Add an input parameter named item of type item base. Add an input parameter named item widget of type iGoods item. Promote to variable named using item. Category for items. Promote to variable named using item widget. Category is items. Determine if no montage animation is currently playing. If true, convert using item to item use base. Call the starUse function. Determine if the time is greater than 0. If false, indicate that it is not needed. If true, display the using item UI. Compile and save. That's it for this lesson. We'll continue with the logic for using items in the next lesson. Hello everyone, I'm Big Cat. This lesson continues with making logic for using items. Open the player controller. Add a function named canSimItem. The category is items used. Add an input parameter named item of type item base. Determine if the count is greater than 1. If true, the count is reduced by 1. Set item change event via player state. If false, call the delete item function. Set the item. If the item is valid, call the distree function. Open the event graph of item use space. Call the consume item function. Add a comment. Open the player controller. Next, play the character's item used animation. Open the item used function. Play montage animation. Select the use animation. Open the event graph of item use space. Get the montage animation that is currently playing. Call the stop playing animation function. Open the DT item tab probability date table. Change the second health to burst. Open goods items on mouse button down. Take this section of the node and collapse it into a function named startUse. Go back to on mouse button down. Call the item used function in my player controller. Add a comment. Open the startUse function of item use space. Set it to true here. Open the event graph of the user info UI. Set all school Y values to 1. Open the designer. Set the X value of the pivot of all energy bars to 0. Run the game. Use energy items. Too many decimal places are displayed. Open the event graph of the use item UI. Set the maximum and the minimum number of fractional digits to 0. Run the game. Use energy items. Display is correct. Modify health value. Run the game. Use medicines. Displayed correctly. No programs bar is displayed when an item is currently being used. Open the item used function of my player controller. Call the item widgets start use function. Run the game. The item is used. The progress bar is displayed correctly. If the UI is closed before use is complete, it will continue to show programs. If it is opened again, open item use space. Add a function named getRemainingTime. Return the use time. Open goods item. Show the progress bar while the UI is being generated. Cast the item base to item use base. Determine if it is valid. Call the start use function. Use need time to subtract the remaining time. Set to time. Run the game. Use items. Close the inventory UI and open it again. The programs bar is displayed correctly. Items in use should be stop when the character moves. Open the player controller. Add function named check use item. Category as items use. Determine if the using item is valid. If valid, cast to item use base. Get if it is valid. Get moon access, and at last one of them is not 0. Determ. Call the stop using function. Hide the useAtom UI. Get the montage animation currently being played by the character. Stop the playing animation. Open the player controller. Call the trick useAtom function in event tick. Add a comment. The atom is stopped. Get atom base. Cast to atom use base. Determine if need time is greater than 0 and currently valid. If false, call the stop use function. Run the game. Use atoms. Move. Stop using the atom. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson creates the energy value to health value conversion function. Open the Use Info UI. When making the energy UI, you should note that there are 4 stages of energy values. The first stage is 1 to 20. The second stage is 21 to 60. The third stage is 61 to 90. And the fourth stage is 91 to 100. Each stage restores health once every 8 seconds and reduces the energy value by 1 point every 3 seconds. During first stage, 1 point of health is restored each time. It lasts 60 seconds. The second stage restores 2 health points each time. Lasts 120 seconds. Stage 3 restores 3 health points each time. Lasts 90 seconds. Stage 4 restores 4 health points each time. Lasts 30 seconds. Open the player controller. Add a function named EnergyAddHealth. Name it EnergyAddHealth. Category atoms used. Add an input parameter named delta. Type float. Determines if the current energy value is greater than 0. Add sequence node. First, create the logic to reduce the energy value by 1 for a cumulative period of 3 seconds. Add a variable named reduce sec of type float of category items use. This indicates the cumulative reduction time. Reduce sec plus data set to reduce sec. Determine if it is greater than or equal to 3 seconds. If greater than or equal to 3 seconds, set reduce sec to 0. Subtract 1 from the current energy value. Add clamp node. Set value and max. Set to energy value. Add comment. Next, make the logic to increase the health value once in a cumulative 8 seconds. Add sec plus data set to add sec. Determine if it is greater than or equal to 8. If true, set add sec to 0. Add the sequence node. Get the current energy value. Determine if it is greater than 90. Get current health value. Add 4. Limit to 0 to 100. Set to health value. Determine if the energy value is greater than 60 and less than or equal to 90. Add 3. Limit to 0 to 100. Set to health value. Determine if the energy value is less than or equal to 20. Add 1. Limit to 0 to 100. Set to health value. Add comment. Open event graph. Call the energy add health function in the event tick. Add comment. Run the game. Use energy items. The health value starts to recover. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we will making the parachute UI. Create a folder in the Blueprint UI folder named Parachute. Create a widget named Parachute UI. Open it. Set the size to 19201080. Add a horizontal box named Height Area. Make the UI that displays the height in this. Set the anchors to be in the center. Set the position X to -445. Set the alignment to 1, 0.5. Check the size to content. Add an overlap. Name it height value area. Set the distance below 50. Align horizontally to the right. Align vertically to the bottom. Add an image. Set the image to height value BG. Add a horizontal box. Add a size box. Set the width to 50 and the height to 34. Add a text box. Name it height TXT. Align vertically to the bottom. Set the text to 1500. Set font to be tab BNT size 23. Outline size is 1. Alpha is 0.5. Text justification is right aligned. Add a text box. Vertical down alignment. Text is set to M. Font set to B, tab BNT, size 60. Outline size is 1. Outline alpha is 0.5. Add an image. Distance from left is -5. The image is set to height axis. Add a horizontal box named Speed Area. This is used to display speed values. Set the anchors in the center. Set the position X to 445. Check the size to content. Add an image. Set the image to speed axis. Set the alignment to 0.5. Add a horizontal box. Add a size box. Set the width to 39 and the height to 34. Add a text named speed.txt. Align vertically centered. Set the text to 249. Set the font to be tab, BNT, and size 23. Outline size is 1. Outline alpha is 0.5. Text justification is right aligned. Add a text box. Vertical center alignment. Text is set to km/h. Font set to be tab BNT, size 60. Outline size is 1. Outline alpha is 0.5. Open graph. Add a function named updateDisplay. Add an input parameter named currentHead, tab float. Add an input parameter named totalHead, tab float. Add an input parameter named speed of tab float. Divide the current head by 100. Convert centimeters to meters. Floor. Set to head.txt. Divide the current head by the total head. Multiply by minus 310. Set to the translation y value of head value area. Divide the speed value by 100 and multiply by 3.6 to get km/h. Floor. Set to speed.txt. Open my HUD. Display the parachute UI. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, an active function. Create a folder under the blueprint folder called Air Navigation. Create an actor named Airplane. Open it. Add the static mesh component and override root. Set the static mesh of the static mesh component to aircraft 130. Compile and see. Add a variable named startPoint. Type vector. Indicates the starting point of the aircraft's flight. Check instance editable and expose on spawn. Add 3. Limit to 0 to 100. Set to health value. Determine if the energy value is less than or equal to 20. Add 1. Limit to 0 to 100. Set to health value. Add comment. Open event graph. Call the energy add health function in the event tick. Add comment. Run the game. Use energy items. The health value starts to recover. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we will making the parachute UI. Create a folder in the Blueprint UI folder named Parachute. Create a widget named Parachute UI. Open it. Set the size to 19201080. Add a horizontal box named Height Area. Make the UI that displays the height in this. Set the anchors to be in the center. Set the position X to -445. Set the alignment to 1, 0.5. Check the size to content. Add an overlap. Name it height value area. Set the distance below 50. Align horizontally to the right. Align vertically to the bottom. Add an image. Set the image to height value BG. Add a horizontal box. Add a size box. Set the width to 50 and the head to 34. Add a text box. Name it head.txt. Align vertically to the bottom. Set the text to 1500. Set font to be tab BNT size 23. Outline size is 1. Alpha is 0.5. Text justification is right aligned. Add a text box. Vertical down alignment. Text is set to M. Font set to B tab BNT size 60. Outline size is 1. Outline alpha is 0.5. Add an image. Distance from left is -5. The image is set to head axis. Add a horizontal box named speed area. This is used to display speed values. Set the anchors in the center. Set the position X to 445. Check the set to content. Add an image. Set the image to speed axis. Set the alignment to 0.5. Add a horizontal box. Add a size box. Set the width to 39 and the height to 34. Add a text named speed.txt. Align vertically centered. Set the text to 249. Set the font to be tab BNT and size 23. Outline size is 1. Outline alpha is 0.5. Text justification is right aligned. Add a text box. Vertical center alignment. Text is set to km/h. Font set to be tab BNT size 60. Outline size is 1. Outline alpha is 0.5. Open graph. Add a function named updateDisplay. Add an input parameter named currentHead tab float. Add an input parameter named totalHead tab float. Add an input parameter named speed of tab float. Divide the current head by 100. Convert centimeters to meters. Floor. Set to head.txt. Divide the current head by the total head. Multiply by -310. Set to the translation y value of head value area. Divide the speed value by 100 and multiply by 3.6 to get km/h. Floor. Set to speed txt. Open my HUD. Display the parachute UI. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, an active function. Create a folder under the blueprint folder called Air Navigation. Create an actor named Airplane. Open it. Add the static mesh component and override root. Set the static mesh of the static mesh component to aircraft 130. Compile and save. Add a variable named startPoint. Tab vector indicates the starting point of the aircraft's flight. Check instance editable and export on spawn. Add a variable named endpoint of tab vector indicates the endpoint of the aircraft's flight. Check instance editable and export on spawn. Add a variable named flying speed of tab float. Indicates the speed of flight in kilometers per second. Set the default value to 11,100, which is 111 meters a second. Add a custom event named Start Flying. Call this event to start the flight. First, set the initial direction and position of the aircraft. Add the find lookat rotation node. Set the start position and end position. Set to actor. Set the initial position. Add comment. Next, use the timeline to control the flight. Add timeline. Name it Timeline Flying. Set length to 5 seconds. Add a float track. Add a key. Time and value are set to 0. Add a key. Time and value set to 1000. Get timeline and call the function that sets the length. Subtract the end position from the start position. Get the length. Divide it by speed of the flight. Get the time it takes to fly. Set. Add comment. Display aircraft when play is completed. Dividing the total time flown by the time flown equals the current flight percentage. Add lerp node. Set. Set the position of the actor. Add a comment. Open construction and call start flight when the character is generated. Compile, save. Next, test. Open my character. Add the keyboard 1 key. Add the spawn actor node. Class set to airplane blueprint. Make transform. Start point set to -28,000, -190,000, 1,500,000. End point set to -100,000, -139,000, 1,500,000. Back in airplane. Flight speed multiplied to 11,100. Run the game. Press the 1 button. The plane flies correctly and is destroyed when it reaches the end. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making a flight path for an airplane. The plane's flight path is random each time. Next, we look at how to random it. Switch to the top view. Select Unlet. Assume that our island is only the size of the land we currently have. Drag in a cube. Set the X scaling to 800 and the Y scaling to 800. This will cover the whole. Add the not in air judgment. Friend the crouch input. Add a not in air judgment. Friend the jump input. Add not in the air judgment. Friend the prone input. Add not in the air judgment. From the Show Inventory UI, add the not in the air judgment. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about creating a parachute flight function. The character needs to fly to a certain position during the flight in the airplane before it can jump. Flying to a fixed distance will also force the character to jump if the user does not perform the jump. Open the airplane blueprint. Add an event named onJumpReady to send a notification that a jump is possible. During the flight, determine if the jump position is reached and call the onJumpReady event. Add sequence node. Determine if the current flight percentage is greater than 0.2. If yes, then 20% of the distance has been flown. Call the ready to jump event. Add an event named onJumpLatest to send must jump event notification. Determine if you have reached the must jump position during flight. If so, call the onJumpLatest event. Determine if the current flight percentage is greater than 0.8. If yes, then 80% of the flight has been flown. Call the must jump event. We want both the can and must jump events to be called only once, so add an unbound after the call. Add a comment. Open my player controller. Bound the onJumpReady event. Bound the onJumpLatest event. Add a function named eject. Category parachute. This is used to perform the logic for the actor jumping off the plane. Add sequence. Unbound synchronized airplane position events. Add a comment. Set character free-falling state to true. Set movement control in effect. Add comment. Set camera position back to third-person position. Add comment. Show character mode. Add comment. Head action tip UI. Add comment. Open event graph. Friend the interaction event. Execute jump logic when the F key is pressed. Determine if on the air. If not, execute pick up item. Determine if it is possible to parachute. Call the eject function. This should be set to true. Run the game. Press the 1 key. Press the F key. Pressing the F key when you are not in a position where you can jump will have no effect. Pressing the F key when prompted that it is ready to jump allows the character to jump out. If the character has not jumped by the time it reaches the position where it must jump, the jump is forced. Friend the jump latest event. Determine that the current state is not fearful. call the eject function. Run the game. Press the 1 key. We do not do anything. The character is forced to jump when the plane reaches a position when must jump. The character will be given a parachute backpack after jumping out of the plane. Create a folder in the blueprint folder named Parachute. Create an actor named Parachute Pack. Open it. Add the static mesh component and override the root component. Set the model to Parachute Pack. Set the collision profile to no collision. Compile, save, open the eject function in my player controller. Display the parachute pack to the character when the character jumps out of the plane. Add comment. Run the game. The parachute pack is now displayed on the character. Open my HUD. Add show parachute UI function. Add head parachute UI function. Show parachute UI. Add a function named trick head. Category as parachute. Add a LangTrace function. The start point is set to the character mode position. Start point +1 distance down. Set endpoint. Object type is set to length. Get distance. Promote to a variable named falling height. Category parachute. Set parachute UI height and speed in real time. Add comment. Open eject function. Add a timer. Event set to check height. Promote the return value to variable named check height timer. Category is parachute. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about making a character that flies after jumping out of a plane without opening a parachute. The character has two speed values while in the air. One is the horizontal movement speed, which is the same as the character moving on the ground. There is also a vertical speed, which is the speed at which the character falls. Open the eject function in my player controller. Set the maximum horizontal movement speed after jumping to 3000 in centimeters per second. Add a comment. Add a variable named terminal velocity, category parachute, for the jump speed. Set the maximum fall velocity to 4167 in centimeters per second. This value is the maximum velocity at which the character can free fall without any action. Get the physical volume object and set the terminal velocity value. Add comment. Add a function named ffsetTerminalVelocity, category parachute, to smoothly set the fall speed when the parachute is not open. Add input parameter named targetSpeed, tabFloat, indicates the final target speed value. Add an input parameter named interp of tabFloat. This represents the interpolated value of the velocity change, which will affect the smoothing effect. Use the finterp2 node to achieve smooth acceleration or deceleration. Set this velocity value to the terminal velocity of the character. Add the function named moveOnTheAir category parachute. Add an input parameter named access of type float. This function will be called when W is pressed while in the air. Determine if access is greater than 0. Limit the range of y-axis rotation values to -90 to 90. Add comment. 0 indicates horizontal flight, and negative values indicates downward flight. Add comment. Maximum speed range for descent 160 km per hour to 234 km per hour. Add comment. Set the horizontal displacement of the character's head orientation. Add comment. The maximum descent speed drops smoothly back to 150 km per hour when the button is released. Add a function named setCharacterRollAngle category parachute. This is used to set the character's pitch angle. Add input parameter named targetAngle of type float. Indicates the angle value to be set. Add an input parameter named interp of type float. Indicates the interpolation of the velocity change. Again, use the finterp2 node to set the pitch angle of the character model. Go back to the move on the air function. Set the pitch angle of the character downwards. Determine if the Alt key is hold down. Keep the y-axis rotation value within the range of 90 to -90. Add comment. Final angle control from 0 to 45. Add comment. Promote to variable named press Alt roll angle category parachute. Call set character roll angle. Add comment. Releasing the W key to smooth the character's pitch angle to 0. Add comment. Create a function named setForwardValue category parachute. This is used to set the forward value variable needed for the character's animation. Add an input parameter named input_access of type float. Still use the finterp2 node to set the speed. Open event graph. From the move area, we have written the functions related to moving on the ground in a function. Add the function named executeMove category move. Add an input parameter named access of type float. Add an input parameter named isForward of type boolean. Select all nodes related to moving on the ground. Copy and paste. You can see that moving forward or backward is the same as moving left or right, except that the direction set when the move on the ground function is called is different. There are also different judgment variables and different setting variables, so we can just use the first node. Setting the direction. The direction is judged before the axis is judged. If it is forward, judge the forward axis. Copy and paste. Modify to move right. Call to update camera head. Set axis. Go back to event graph. Delete all nodes related to movement. Get whether the camera is currently in fair fall. Get whether the parachute is open or not. If not flying in the air, then on the ground, call the execute move function. Set axis. Set forward to true. Copy and paste. Set axis. Set forward to false. Compile, save. Run the game. Move on the ground normally. Next, make a function to fly in the air. Add a function named execute flying category parachute. Add an input parameter named axis of type float. Add an input parameter named isForward of type boolean. Determines if it is in fair fall. Call the moveForward function. Call the setForward value function. Add comment. Move logic to the left or right. Add comment. Open event graph and call the execute flight function. Friend the Alt key. Response area. Set the action properties. No restrictions on up and down. Wheels are needed when flying. Determine if you are in the air. If in the air, skip the restriction. Run the game. The character can move towards the HUD when the W button is pressed, and you can adjust the character pitch angle with the mouse direction. The more the HUD is facing downwards, the greater the speed of the character's fall. Next, set the character to move sideways in the air. Open my character. Select the movement component. Friend the section about jumping. Set air control to 1. This is a value that can be set between 0 and 1. If it is 0, our controller will not control the character's lateral movement. If the value is 1, it will have full control. Set the braking deceleration falling value to 2000. The character's lateral movement speed will automatically be reduced to 0 when lifting the A or D key if this value is set. Open my player controller. Untrick is forward. Modify the arrow. Run the game. Press 1 to get on the plane. Jump off the plane. Press the A or D button. The character starts to play a lateral movement animation and starts moving sideways. Release the button and the character animation lesson. Hello everyone, I'm Big Cat. This lesson creates the open parachute function. Create an actor in the parachute folder named parachute to display the parachute. Add a skeletal mesh and override root. Set the mesh to SKM parachute. Create a custom event named playLandEnemy to play the parachute animation on landing. Play the AS parachute land animation. Create a custom event named playOpenEnemy to play the parachute opening animation. Place the AS parachute open animation. Delay by 1.958 seconds. Add comment. Play idle animation. Open character skeleton. Add socket for parachute. Create a socket under spawn 03 named socket parachute. Add the preview resource skm parachute to the parachute socket. Set the character's preview animation to fair parachute. Set x-axis rotation to -90. Set y-axis rotation to -90. Set z-axis rotation to 90. Set x-axis position to -125. Next, create the parachute opening logic. Open my player controller and add a function named Open the Parachute. Category Parachute. First, check the earliest opening height. Add comment. Play parachute animation. Add a comment. Rotate character angle. Add comment. Set the character state. Add comment. Hide the tip. Open event graph. After opening the parachute, the camera pulls away from the animation. Add a custom event named Play Open Parachute Camera Anime. Add a timeline named Timeline Open Parachute Camera Anime. Set the length to 0.35 seconds. Add a float track named Value. Add key with time 0 and value 300. Add key with time 0.35 and value 1000. Delay 0.667 seconds to start playing. Set spring arm. Add comment. Open the Open function. Call the Play Open Camera Animation function. Open event graph. Find the response F button. Next, call the Open Parachute logic. Determine if the current state is fearful. If so, call the Open Parachute function. Determine if the parachute is not open. If so, call the eject function. Flat the tick. There is no need to synchronize the rotation values after opening the parachute. Run the game and press the F key when falling below 1000 meter. The character can open the parachute correctly. Turn on the check hat function. Prompt to open the parachute when the character reaches 1000 meter in altitude. Add comment. When the character drops to 300 meters in altitude, the parachute opens automatically if it is not already open. Add comment. Run the game. The parachute will Hello everyone, I'm Big Cat. This lesson is about making a parachute flight. Open my player controller. Add the function named getForwardScale and category parachute. This function is used to smooth the transition from stationary to moving, cheek pure. Add an input parameter named access of type float. Add an output parameter named score value of type float. This value is used to set the parameters when panning. Add a variable named forward scale. Of type float. Category is parachute. Determine if access is greater than 0. Greater than 0 means forward. Use forward scale plus. Delta divided by 5. Limit to 0 to 1. Set to forward scale. Copy and paste. Go backward, change to minutes. Return. Open the Move on the Air function. Call getForwardScale and set access. When the character is in the open state, there are 4 drop speeds. Open the execute flying function. Add an input parameter named redaccess of type float. Use forward access and redaccess. Add comment. Add sequence node. Hold Ctrl key for 11 km/h. Add comment. Speed of 53 km/h when holding down the W key. Add comment. 27 km/h when only the A or D key is held down. Add comment. Speed is 25 km/h when no action is pressed. Add comment. Next, create a function to set the pitch angle of the character. Add a function named setCharacterPitchAngle, category parachute. Add two input parameters. Use the finterp2 node. Open the execute flying function. Add comment. Determine if the current is forward. Move in the direction of the hand. Add comment. Set the character x-axis rotation. Add comment. Set the character z-axis rotation. Add comment. Set the character y-axis rotation. Add comment. Replace this judgment with sequence. Replace all right axis with move right. Replace all forward axis with move forward. Run the game. Open the parachute. Press and hold the W key for a maximum descent speed of 52 km per hour. Press and hold A or D at the same time for a maximum distance speed of 27 km per hour. If you do not press any key, the distance speed is 25 km per hour. Holding the next lesson. Hello everyone, I'm Big Cat. This lesson is about creating a landing feature. Open my player controller. Add the function reset to land. Category parachute. Remove the chick head event. Add comment. Remove the parachute and parachute back. Add a comment. Open event graph. Play the landing animation. Now options are allowed while the animation is playing. Add a custom event named Play Land Aim. Hide the parachute UI. Play the parachute landing animation. Delay 1.967 seconds for the animation to finish. Set the character to be able to move. Call the reset to land function. Show the character UI. Add comment. Open my character's event graph. Add the unland event. Determine if the character is in the air. Restore the base properties. Add a comment. Set the maximum speed to working speed. Add comment. Set the rotation value. Set the camera to its initial position. Add comment. Call the playLandAim function in my player controller. Stop the character movement on landing. Run the game. Hello everyone, I'm Big Cat. From this lesson, we will be working on the safe zoom related features. In this lesson, we are going to create a safe zoom display. Create a folder in Blueprint named Safe Zoom. Create an actor with the name Safe Zoom BP. Open. Add a static mesh component, replacing root. Set this static mesh to SafeZoom Sphere. This is a circular model. The default for this circle is the 1 meter diameter. Set the collision prefab to custom. Set to query only. Set the tab to be static. Keep prompts overlap only as it needs to detect the entry and removal of characters. Create a variable, init_diameter, of tab float to indicate the diameter of the initialized safe zone in meters. Check the editable instance and check its pause on spawn. Open construction script. Call the model's setScaling function. Set the initial diameter to the x-axis and y-axis scaling. Set the z-axis scaling to 10,000. The z-axis scaling controls the height, which is always constant. Add a variable named final scale. Tab vector indicates the final scaling value of the safe zone. This final scaling value is the value to which the safe zone will finally be scaled down each time it is scaled down. Set the initial diameter to the final scale value. Add a variable named final partition of tab vector. Indicates the final partition value of the safe zone. The safe zone will continue to move position as it shrinks, and this value indicates the value to which it will finally move. Get the current actor position and set it to the final position value. Next, create the safe zone shrink function. Open event graph. Create a custom event with the name start to shrink. Add input parameter named final position tab vector. Add input parameter named final diameter of tab float. Add input parameter named delayed start sec tab float. This indicates how many seconds this reduction will be delayed to start. Add input parameter named duration of tab float. Indicates the duration of this reduction in seconds. Add sequence node. Get the current actor position and promote it to a variable named start position. Indicates the start position of this shrinkage. Set the final position to the variable. Get the current scaling value of the model. Promote to a variable named start scale. Break the scaling value of the model, setting the z value to the variable. Add comment. Delay. Add timeline, name it timeline shake. Add key set to 00. Add key set to 3000. Set the length of the timeline. Set the position. Set the scale. Delete itself if the scaling value is 0 when finished. Add comment. Add comment. Open my character's event graph. Create a safe zone. Call the shrink function. Set the final position. The final diameter is set to 50. Delay 5 seconds to start. Duration 5 seconds. Initial diameter set to 100. Run the game. Press the 1 button. Start shrinking after 5 seconds. Takes 5 seconds to shrink to the specified position. Return to the safe zone blueprint. Add a function called current position to get the current position of the safe zone. Note that currently refer to the position when the shrinkage is complete, not during the shrinkage. Select peer. Add output parameter named diameter. Hello everyone, I'm Big Cat. Let's start with an explanation of the safe zone scaling rules. We can set the number of times the safe zone scales. There is a delayed start time before each start of scaling. There is a duration during the scaling process. Each time you zoom in, you need to set a zoom ratio. 0.5 means that the final diameter after this zoom is 0.5 times the diameter before the zoom. If the character is outside the safe zone, it will take damage continually, dealing damage every second. Next, put this data into a data table. Create a structure in the blueprint data's table structure folder and name it st safe zone. Open it. The first variable is named delayed start sec and type float. This indicates the number of seconds to start the delay. Add a variable named duration type float, indicates the duration of the scaling. Add a variable named scaling type float, indicates the scaling ratio. Add a variable named damage type float, indicates the value of damage per second. Create a data table in the data table folder and select st safe zone. Name it dt safe zone. Open it. Row 1 is set to 155.0.51. Row 2 is set to 255.0.52. Row 3 is set to 333.0.53. Row 4 is set to 433.0.54. Row 5 is set to 522.0.55. Row 6 is set to 622.0.56. Row 7 is set to 7111010. A scaling of 0 means that there is no safe zone. The safe zone is randomly positioned, one position at a time each time. It is scaled down. Next, do a test. Open the level, drag in a cube, and set the scaling to 0.1. Open the level blueprint. Create a cube reference. Draw a circle with the cube as the center, representing the size of the safe zone when it is not scaled. Call to draw a coin. Get the position of the cube and set the starting point given to the coin. Set the z-axis direction to 1. Set the angle to 90. Set the number of sides to 30. Set the duration to 1000. Set the thickness to 0.5. Run the game. You can see a circle that is horizontal to the ground. This is simulated as the current safe zone. Next, randomly select 100 points as the end point. Add a loop node and set the last index to 100. Add a line drawing function. Set the start point. Set the color to red. Set the duration to 1000. Set the thickness to 0.5. Add the random unit vector in coin in degrees node. Returns a random vector with length of 1 within the specified coin with uniform random distribution. The base center direction of the coin. Set the z-axis to 1. The half angle of the coin. Set the angle value to 90. Multiply this return value by 100. Use the position of the cube plus this value to be the end of the line end. Run the game. The direction of the line needs to be modified. Expand the return value. Make vector. Set x and y, z to 0. Run the game. All the points that come out randomly. Watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we make the safe zone continuous shrink feature. Open my game mode. Add the variable named SafeZoneBP. Type SafeZoneBP object and category SafeZone indicates the current SafeZone blueprint object. Add variable named number of times. Of type integer. Category SafeZone indicates the current number of SafeZone shrinkage times. Add function named random SafeZone for the random SafeZone location. Add output variable named isOver of type boolean indicates if it is over. Add output variable named final position of type vector indicates the final safe zone position after shrinking. Add output variable named final diameter of type float indicates the diameter of the reduced final safe zone. Add output variable named delayed start SEC of type float. Add output variable named duration type float. Add output variable named damage type float. Calculate the final diameter after this reduction first. Add a getDateTable node and select the SafeZone datetable. Get the current count and set the name of the given row. Get the current SafeZone object. Multiply the current scaling value by the scaling ratio. Promote to a local variable named diameter. If non-relevant data is found in the datetable, then the SafeZone scaling has ended. Return to end. Add a comment. Then calculate the position of the scaled down safe area, which is a random position within the valid range. Valid means that the reduced area must to be within the area before the reduction. Add the node. Set the z-value to 1 and the angle to 90 degrees. Make vector, set x and y. Multiply by the length value. Use the diameter divide by 2 to get the radius. Multiply by 100 to convert to centimeters. Use this value plus the current position of the safe zone to be the final position. The z value needs to remain the same. Expand. Make vector, set the x and y values. Set the z value. Return. Next, make the logic related to continually shrinking the safe zone. Open event graph. Add a custom event named start safe zone. Spawn a safe zone. Set the location to the center of the entire map with the same z-axis value as the horizontal plane. Set to safe zone BP. Add 1 to the content variable before randomizing one position at a time. Call the random safe zone function. Determine if it has ended. If not over, promote the damage value to a variable named safe damage and category safe zone. Call the start once shrinking function of the safe zone. Set variables. Add delay node to continue calling the shrink function after one shrink execution is complete. Use a delete start time plus a duration. Add a comment. Set the initial diameter to 500. Open the random safe zone function. Set to false here. Run the game. The safe zone is reduced according to the data in the date table. That's it for this lesson. Thanks for watching and we'll see you next lesson. Next, create a sense effect of the character being outside the safe zone. Add a function named entry or out safe zone, category safe zone. Add an input parameter named out and type boolean, indicates whether it is move out. Return to the safe zone blueprint. Call the entry or out safe zone function. Set out. Add variable named callout of type boolean, indicates whether the moveout function has been called. Add a variable named callIn of type boolean, indicates whether or not the in function has been called. Determine the call variable first, then call the function. Add comment. Open my character. Select the third-person camera component. Add a post-process material. Select the inst post material. Run the game. You can see that the scene has a glass text effect. In the camera, options set the post-process wait to 0. Go back to the function. If you are moving out, set the wait to 1. If you are entering, set the wait to 0. Run the game. No post effects are displayed by default. Show on-screen post effects when the character is moved out of the safe zone, and hit post effect if the character re-enters the safe zone. Next, make the character deal damage when outside the safe zone. Add an input parameter named damage of type float. Promote the damage value to a variable named safe zone damage and category safe zone. Promote whether to move out to a variable named isOut, category safe zone. Open the safe zone blueprint. Add an input parameter to the start shrink safe zone function named damage type float. Promote the damage value to a variable named damage. Set the damage value. Open my game mode. Set the damage value. Open player controller. Add function named calculate safe zone damage, category safe zone, used to calculate safe zone damage. Add input parameter named delta of type float, indicates the time value of tick. Determines if the safe zone is currently moved out of the safe zone. If moved out, set health value via player state call. Multiply the damage value by delta to get the damage at this time. Get the current health value via player state. Subtract the damage value. Add clamp knot. The minimum value is 0, the maximum value is 100. Open event graph. Call this function in tick. Add a comment. Run the game. Hello everyone, I'm Big Cat. We are starting this lesson by making an airdrop feature. Let's start this lesson by making the airdrop plan actor. Create a folder under the blueprint folder named airdrop. Create an actor with the name airdrop plan. Add a static mesh component and replace root. Set the model to aircraft 130. Set to no collision. Add a variable named start point of type vector, indicates the start point of the airdrop plan flight. Check the instance enabled and expose on spawn. Duplicate, named drop point, indicates the drop point. Add a variable named airspeed, type float, indicates the airdrop plan flight speed. Set the speed value to 10,000. This is in kilometer per second. Open event graph. Add a custom event named start to airdrop. Set the initial position and direction of the airplane. Add a comment. Flying from the starting point to the thrusting point. Add comment. Calculate the end of flight. Add comment. Flying from the closing point to the end. Add comment. Open construction to call the start to airdrop event. Automatically starts the flight when the airdrop has been created successfully. Open my character's event graph. When 1 is pressed, an airdrop is created. Run the game. Hello everyone, I'm Big Cat. In this lesson, we are going to make airdrop box. An airdrop item is a box that contains multiple items that can be picked up. The classes that can be picked up are all subclasses of pickup base. This box contains multiple pickup base. Create an actor in the airdrop folder named airdrop box. Add a static mesh component named box to display the airdrop box and override the root. Set up the static mesh. Add a static mesh component and parachute to box to display the airdrop parachute. Set up the static mesh for parachute. Add a particle system component named smoke to the box to display a smoking particle effect. Set the particle effects. Select the box component. Start the physics simulation. Set the mass to 60,000 in kilogram. Set linear damping to 2. Set angular damping to 2. Set collision to physical actor. Select the parachute. Set the z-axis position to 72. Set parachute scaling to 0, which will be animated later. Set collision to no collision. The particle effect will only play when the box hits the ground, so set the particle effect auto activation to false. Open event graph. Next, create the opening parachute animation. Set the scaling performance of the parachute to show the animation. Next, determine if it has landed. We use the z-axis velocity of the object to determine if it has landed or not. Add a comment. Execute once. Turn off physical functions. Add a comment. Delay 0.2 seconds. Remove the parachute and start playing smoke. Add comment. Delete the smoke after it has lasted for a while. Add a comment. Add a variable named cantique, type boolean. The object is created with a speed of 0, so a delay time needs to be added. Open airdrop plans, event graph. Create the airdrop box at the end of the first session of the flight. Add a comment. Run the game. Press the 1 button. Jump out. The drop box is thrown. The parachute. Hello everyone, I'm Big Cat. In this lesson, we will make items that are in airdrop box and can be picked up by your character. Let's start by making the airdrop item data table. Open the data's table structure folder and create a folder named airdrop. Create structure named st airdrop box item. Add variable named sn tab string. Add variable named item tab item tab. Add variable named id tab name. Add variable named amount tab integer. Open the event graph for airdrop box and add the variable items info, an array of tab st airdrop box item. This represents all the items in the box. Check instance enabled and expose on spawn. Create a pick up item object when an airdrop box lands. Change do once to set can tick to false. Add sequence node. Promote relevant variables. Copy the node that creates the item from my game mods generated items function. Modify the variables. Add to the pick up items array and reactivate collision detection. Add comment. Bounding for item overlap event. Add a comment. Add a comment. Open airdrop plan. Add variable items info, an array of type st airdrop box item. Check instance editable and export on spawn. Set items info. Open my character. Add 3 items. Run the game. Press the 1 button. Open the inventory UI next to the box. The items are Hello everyone, I'm Big Cat. This lesson is about the rules for making airdrops. Open my game instance. First, make the number of times rule. Airdrops are made at regular interval during a game. Add a variable named airdrop interval time, type float, and category airdrop. Indicates the time between airdrops. Set the value to 5 seconds. Add variable named airdrop number of times of type integer. Category as airdrop. Indicates the total number of airdrops. Set the value to 5 times. Open my game mode. Add a custom event named start airdrop. Add a delay time. Copy from my character. Add variable named number tab float category as airdrop. Indicates the number of times the airdrop has been executed. Add the number of times once. Determine if it is less than or equal to the total number of times. Execute in a loop. Call this function when the game starts. Next, make the job location. The job location is a random location within the current safe zone. Open the random safe zone function. Copy the random location and paste it. Set the z value of the final location to 30,000, which is 300 meters high. Set to the throwing point. Select collapse into a function named getAirdropJob and category as airdrop. Check pure. Back in event graph, the starting point of the aircraft flight is 1 as soon as it is on the edge of the map. This function can be used with the random aircraft starting point function in the skydiving course. Call the random rule function. Select it, collapse it into a function named getAirdropStart and category as airdrop. Next, make a random item rule. Create a table of data that holds all the possible items and their chances of occurring. Create a structure in the data's table structure airdrop folder named st airdrop items. Add variable named item tab of tab item tab. Add variable named id of tab name. Add variable named amount of tab integer. Add variable named % of tab integer. Create a folder in the Data's datetable folder named airdrop. Create a datetable and select st airdropped items. Name it dt airdrop items. Set up the item information. Open my game instance. Add a variable named airdrop item amount. Type integer, category as airdrop. Indicates how many items are in an airdrop box. Set the number to 2. Go back to my game mode. Add a function named getAirdropItems. Category as airdrop. Start by putting all items into an array according to probability. Break up the order. Get the items at runtime. Go back to event graph. Call the getAirdropItems function. Modify the safe zone to 1. The game starts executing safe zones. Run the game. All airdrop will be randomly dropped into the current safe zone. Hello everyone, I'm Big Cat. Start this lesson by creating the Bowman area feature. Create a folder in the Blueprints folder and name it Bowman area. Create an actor named Blast Point. Use this to represent the blast point. Open it. Multiple particle effects show the blast effect. Add a particle effect component. Set it to P Bowman area blast 1. Set the z-axis position to 120. Add a particle effect component. Set to P Bowman area blast 2. Set the z-axis position to 70. Add a particle effect component. Set to P Bowman area fragmentation. Set the z-axis position to 100. Add a particle effect component. Set to P Bowman area small objects. Set the y-axis position to minus 60 and the z-axis position to 100. Add a sphere collision component. This is used to detect collisions. Set the scale to 30. Set the z-axis position to 100. Set collision preset to custom. Set query only. Set overlap with pawn only. Add the begin overlap event for the sphere collision component. Next, make the blast detection function. Delay the end of collision detection by 0.1 seconds. Add the sequence node. Display the effect when it finishes playing. Add the gate node. Delay 0.1 seconds to end detection. Determines if the overlap object is a character. Character costs health when the blast point touches the character. Open my player controller. Add function named character touched bomb. Category bomb area. Add an input parameter named distance of tap float. This represents the distance of the character from the center of the blast. Add a local variable named damage of tap float. Indicates the damage value. Add the sequence node. Determines if the distance is between 0 and 5. Set damage to 100. Determine if the distance is between 5 and 15. If so, set damage to 70. If not, set damage to 50. Set the character health value. Go back to the blast point blueprint. Call the character touched bomb function. Open my character. Generate a blast point at the character's location when keyboard key 1 is pressed. Open blast point. Uncheck Start Closed. Run the game. Press the 1 key. 100 health points reduce the character. Add 3 to the position of the bomb. Run the game. Press 1. 70 health points. Reduce the character. Add 50 to the position of the bomb. Run the game. Press the 1 button. 50 health points. Reduce the character. Hello everyone, I'm Big Cat. This lesson is about making a blueprint of the bombing area. Let's start by making the bomb data structure. Create the structure in the data's table structure folder named stbomb. The first variable is set to point, and the tab is vector. This indicates the location of the blast. Add a variable named blast time of tab float, indicates the time of the blast. Create an actor in the bombing area folder named bombing area. Add a variable named bomb data, tab array of bomb data structure. This is used to save all the bombing point data. Add variable named delay time of tab float, indicates how many seconds to delay the start of the bombing. Check instance edible and export on spawn for all variables. Add a variable named direction of tab float. This indicates how long the current bombing area has lasted. Add a variable named start of tab boolean, indicates whether or not the blast can be started. Start after the special time. Determines if it is ready to start. Add time. Determines if there are bombs. Loop all the bomb information to find the point where it can be blasted. Add a comment. Delete the blasted bomb. Break. If there is no bomb message, destroy itself. Open my character. Create a bombing area. Add 5 bombs. Run the game. Press the 1 button. The bombing area blasts correctly. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is to make the rules for the bombing area. Let's start by explaining the rules of the bombing area. The first point is that it is done the regular intervals. The second point is that there is a total number of bombings. The third point is that each time a character's location is found, multiple random locations within a radius are bombed with that character as the center point. The fourth point is that each bombing has a certain number of blasts. And the fifth point is that each blast is random within a center time. Open my game instance. Add a variable named bombing interval for the interval time. Category is bombing area. Set the value to 50. Add a variable named number of bombings to indicate the total number of bombing area. Set value to 2. Add a variable named bombing radius for the bombing radius. Set the value to 30,000. Add the variable number of blasts for the number of bombings. Set the value to 5. Add a variable named direction of blast for the direction of the blast. Set the value to 5. Open the event graph of my game mode. Add a custom event named Start Bombing. Add a variable named current times for the number of times the area is currently being bombed. Category is bombing area. Add variable named bomb data for the current bomb data. Clear the bomb data. Loop the number of blasts. with the character as the center of the circle, random positions within the radius. Add comment. Random blast times. Add comment. Add to the bomb array. Start creating bomb objects when the loop is complete. Add 1 to current count. Determine if the current count is less than the number of bombs. Delay a time. Add the bomb interval time to the blast direction. Then repeat the execution. Open my character. Call start bombing. Open my game instance. Change the interval time to 3 seconds. Open the safe zone date table. Set the delayed start time to 50. Run the game. Correct. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. Starting with this lesson to create the map UI. The big map and the small map use the same widget. We use the material to make the map UI, and later we will move the map by operating the UV. Under the Assets UI Map folder, there is a Map Material Minimap test. This image has an aspect ratio of 1:1, better for calculating values, and the pixel value should be the second power of 2, as it will be more memory efficient. You can choose the location of this image, but it is important to find the coordinates of the center of the image in the sense, as many of the calculations will need to be done later. Create a cube with the locations -71003, -171,670, 46554. Select Snap View to Object. Change the angle. Create a Map UI image using the engine's High Resolution Screenshot function. Click on the small arrow. Click on High Resolution Screenshot. By adjusting the magnification, you can increase the output image's resolution. Click on this button to output the image. Next, create the material. Create a folder in the UI folder named Map. Create a material named Map UI. Set the material domain to UI. Add a texture sample node. Set the image to minimap test. Connect the texture sample to final color. Next, build the map widget. Create a widget in the map folder named Map UI. Set the screen scrolling to custom with a width of 1080 and a height of 1080. Build the interface. Check the canvas and set the clipping method to clip to bounce. Anything beyond 1080 will be cropped out when the map image is zoomed in with this property checked. Both the Big Map UI and the Sim Map UI use this widget, so different states need to be distinguished. Open graph. Add a variable named isSmallMap. Type boolean. This indicates whether the map is currently small. Check instance editable and export on spawn. Next, create the Big Map UI. Create a widget in the map folder named Big Map Area. Open it. Drag in the map UI. Set the size to 1080. Set the anchor point to be the center. Set the position to 00. Set the alignment to 0.5. Next, create the small map UI. Create a widget in the map folder named Small Map Area. Show the weapons on the left and the map on the right. Add the horizontal box. Add the vertical box. Add a horizontal box named Weapon Right. Show right hand weapon. Add component showing number. Duplicate. Adjust properties. Add size box component. Add map UI. Open my HUD. Create the big map and small map UI. Open my player controller. Determine whether to show or hide the big map UI and the save map UI when the show map button is pressed. Add comment. Run the game. The same map is displayed in the bottom right corner. Press the M button, toggles the display of the big map and the same map. Next, make the display weapon logic. Open small map area. Get the player state. Get the update of the two weapons and the hold state. Set the display according to the state. Run the game. No weapon. Weapon icon hidden. Pick up a weapon, and the weapon icon is displayed. The icon for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. We create a big map drag and drop movement and zoom function in this lesson. The movement of the big map is achieved by setting the translation in the border component render transform. Select the border component. Adjusting the translation will enable the movement. Scaling of the big map is achieved by setting the scale in the image component render transform. Select the image. Adjust the scale to enable scaling. Override the on-mouse button down function. This function is triggered when the mouse is pressed. Call the detect drag if pressed node. Drag and draw the button to select the left mouse button. Set mouse event to pointer event. Set the return value. Create variable. Name it is drag. Type is boolean. Used to indicate whether dragging is currently taking place. Override the onDrag detected function. Triggers this function when dragging is detected. Set is drag to true when dragging is detected. Override the on-mouse button up function. This function is triggered when the mouse is released. Set is drag to false when the mouse is released. Return handled. Override the on-mouse view function. Add a variable named BigMapZone. Type float indicates the current zone value of the map. Set the default value to 1. Set the render scale of the map image. Get the view data via mouse event. Print this data value and see what the value is. Run the game. Scrolling up is +1. Scrolling down is -1. If scrolling very fast, this value will change if your mouse wheel scaled very far. However, scrolling up is positive and scrolling down is negative, which does not change. Delete the print node. Use data multiplied by 0.1. This resultant value is the number of times the mouse scroll is scaled for each scroll. Use the current zoom value plus the multiplier to be scaled this time to be the zoom value of the map after this scale. A limit is placed on the final zoom value. The minimum value is 1 and the maximum value is 4. The actual size of the map image is 4096, so the maximum zoom is 4x. Set this value to BigMap zone. Connect the Set Render Scale node. Use the BigMap zone value to set scale X and scale Y. Add comment. Run the game. Press the M key to open the big map. Scroll the mouse wheel to zoom in and out of the map correctly. Next, make a move function. Override the onMouseMove function. This function is triggered when the mouse moves. First, determine if its drag is true. If its drag is true, the mouse is pressed and the map can only be moved. Then, it determines if the current map zone value is greater than 1. When the zone value is 1, the map cannot be moved in its smallest state. The getScreenSpace position node is obtained via mouse event. This node gets the current position of the mouse. The getLastScreenSpeed position node is obtained via mouse event. This node gets the position of the last mouse movement. Subtract them to get the distance the mouse has moved. Multiply this by the current zoom multiplier, and this value is the offset needed for this mouse movement of the big map. Get the render transform of the map border component. This translation is the current position of the map. Add the offset value, which is the position the map needs to be moved to. Get the map border, set its render translation. Set the x, y values. Run the game. When the map is minimal, it cannot be dragged. The map can be zoomed in via the mouse wheel, and the big map can be moved via mouse dragging. But we find that the map may be dragged out of bounds, so we want to restrict the movement bounds. Add limits to x and y. Use the value after the limit to set the translation. Use the current zoom value -1 to get the magnification. Use the 1080 multiplied by 0.5 to get half the size of the map. Multiply these two values together to get the maximum value of the current zoom translation. Set the maximum value to the max parameter. Multiply by -1 to obtain the minimum value of the translation. Set to the min parameter. Run the game. No matter how you zoom in, dragging the map will not take you beyond the borders. Zoom out at this point, and you will see that the big map runs out of UI range. Connect the return node. Set return to handled. Add a comment. Add a comment. Open a mouse wheel function. Add branch. If wheel delta is less than 0, prove that it's scrolling down. Then, determine that the current zoom value is not 1. A big map cannot be shrink when the current zoom value is 1. If these two conditions are met, the edges of the image needs to be detected. If the map image is out of UI range, we need to move the map back. Get the map border. Set the map border's render translation. First, get map border's current transform. Split the transform. Split translation. This translation is the value of the position of the big map after it has been shrink. If this value is out of the UI range, you need to modify this value. When the map image is red in the middle, the x and y value are 0. So, the corrected x value ranges from 0 to the current x value. The corrected y value is smaller 0 to the current y value. Use the current zoom value -1 to obtain the zoom magnification. Use the maximum zoom available -1 to obtain the actual full zoom. Use the current zoom value divided by the maximum zoom available. Get the current zoom as a percentage of the maximum zoom available. Set the alpha. Set the value after lerp to map border. Connect the return node. Set return. Run the game. Zoom in on the big map first, then move, then zoom in on the big map. Display correctly. And we'll see you next lesson. Hello everyone, I'm Big Cat. Both the big map and the small map display an icon to indicate the character's current position and direction. In this lesson, we will create the character icon function. Add the overlay component named character icon. Set both the horizontal and vertical directions to be center. Add an image component named direction image, used to display a directional image. Set the image to triangle mine. Set both horizontal and vertical direction to the center. Add the image component. Set the image to circle. Set both horizontal and vertical direction to the center. Add a text component. Set both horizontal and vertical to center. The default display is 1. Set the font. Set the outline. Next, update the display for the character direction in real time. Add the sequence node. Get the direction image. Call the setRenderTransformAngle function. Get the rotation value of the controller. Using the current character z-axis rotation plus 90 is the value rotated in the UI. Set. Run the game. The character direction will follow the character's rotation in both the big and small map. Add a comment. Next, make the character position seen function on the big map. The small map character is always in the center, so there is no need to sync the position. Move the position of the character icon on the big map according to the character's position in the sense. Determine if the map is not currently small. Set the character icon's translation. First, calculate the percentage offset in the character's x and y-axis directions, using the center point in the sense as a base. Get the actual position of the player pawn. Use the x position to subtract the scene's center. Divided by half the length of the scene in the x-axis direction. In the UI, the center point has a value of 0, 0. So the coordinates in the scenes are also calculated as if the center point is 0, 0. The horizontal length in the UI is 1080, and the center point is 0, 0. So it needs to be divided by 2, which is 540. This value is the position of the character icon on the UI when the UI is not scaled. Finally, multiply it by the current scaling. Set the value to render translation. The y value is calculated in the same way as the x value. The enter point of the y-axis in the map is -171670. Set the value to render translation. Add comment. Run the game. Open the big map to move. The character position on the map is displayed correctly. That's for this lesson. Thank you for watching. And we'll see you next lesson. Hello everyone, I'm Big Cat. The character icons don't move in the small map, but the map image moves. In this lesson, we make moving UV. Open map UI. Create the texture coordinate node. This node is the texture coordinate. Create the scalar parameter named zoom. This parameter represents the map zoom value. Set the different value to 1. Multiply the original UI value by the zoom multiplier to get the scaled UV value. Create a parameter named x, indicates the percentage to be shifted horizontal. The value of the parameter x has a range of -1 to 1, while the range of values in the UV is 0, 1. So, divide by 2. Since the small map has a zoom value, the zoom value is used and divided by 2. Zoom is divided by 2 because zoom scales the diameter, and we need to use the radius in UV. Add a subtract node. Set A to 0.5. B is the zoom value. Use 0.5 minus the zoom radius value, because the character is always displayed right in the middle of the map. Add an offset value of x. This value is the value to be offset in the horizontal direction. The y offset value is calculated in the same way as the x offset value. Add an append node. Use x and y to form a vector. Use this vector to add to the UV. Add a clamp node. Limit the final value of this to a range of 0 to 1. Attach to the UV of the texture. Add a comment. Let's do a test. Change the value of the zoom parameter to 0.5. You can see that the map in the preview is enlarged by a factor of 2, both horizontally and vertically. Set the zoom parameter to a value of 1. Set the x and y values to 1. This means that the character has gone to the bottom right corner of the map and is positioned in the middle of the map. We first that there seems to be a problem with the display of the area outside the map. When there are no more texture to display, the last pixel point in the texture is automatically stretched infinitely. So, this is what happens now. We can fix this by making the map larger so that the character can't walk to the edge of the actual map. Set the default values for x, y to 0. I've summarized how UV movement works, and you can watch it in slow motion. See you next lesson. Hello everyone, I'm Big Cat. This lesson is about creating the logic related to the movement of the small map. Open the graph of map UI. Add the sequence node. Create a dynamic material instance. Select map UI as a resource. Promote as a variable and name it map. Set the map image material. At this point, the material used at runtime is the dynamically created material. Add a comment. The small map will zoom in many times by default. Determine if it is a small map. Call the function that sets the material parameter. The parameter name is zoom. The parameter value is 0.1. Add a comment. Character movement happens in real time, so complete the logic for moving the small map in event tick. Determine if the map is currently small. Set the x and y parameters of the map mat. Get the current position of the pawn. First, calculate the percentage value of the current character in the x-axis direction. Use the current position x value minus the center point. Divide by half of the map. This value is the percentage offset in the x direction, set to the parameter x. Same for parameter y. Set to parameter y. Add a comment. Run the game. Move the character and the small map will update the position in real time. That's it for this lesson. Thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. The safe zone will be displayed in the 3D scenes on top of the big and small map and synchronizing the status in real time. The display of the safe zone consists of two parts. One is outside the safe zone and needs to be filled with color. The other part is inside the safe zone, filled with white circles to indicate the extent of the safe zone. Both parts are implemented using material. First, let's create the outside safe zone field function. Open map UI. Create a radial gradient exponential node. This node uses UV channel 0 to produce a radial gradient and allows the radial and center point offset to be adjusted. With this node, we can achieve a safe out-of-zone circular fill. Connect the UV nodes. Center position is the position of the center of the circle. Two parameters are created, named zone x and zone y. Zone x is the position of the center of the circle on the x-axis. Zone y is the position of the center of the circle on the y-axis. The append node is used to form a vector of x and y. Set this vector to the position of the center of the circle. Add a parameter named zone radius. This is set to the radius. Density controls the density of the gradient. Create a constant. We don't want a gradient at the edge of the circle, so we set this value to 512. Set to density. Create a vector named zone color. This is used to set the color of the circle. RGB is set to 0, 0.03, 0.35. A is set to 0.8. Use the color values to multiply with the circle. Then, add to the texture. Set to final color. If you draw a circle that fills the entry texture with the center of the texture as the center, then the radius is 0.5. Set the default value of zone radius to 0.5. In the preview window, you can see a blue circle drawn, but the center of the circle is positioned in the top left corner. The zone x value is the percentage of the current position of the safe zone about the whole map, which is 0, 0 in the middle of the map, or -1 on the far left of the map, and +1 on the far right of the map. If converted by percentage and takes a range of -1 to 1 in UV, it takes a range of 0 to 1. So this value needs to be divided by 2 first. In the middle is 0, 0, and in the upper left corner of the UV is 0, 0. So you need to add 0.5 to this value. At this point, you can see that the x-coordinate in the preview sense goes to the middle of the screen. Zone y is set in the same way. The circle is in the correct position and size. Subtract this value using 1 to get a circle with a hollow inside and a solid outside. Set the zone radius value to 1, not showing the safe zone by default. Add a comment. The safe zone will also display a white circular coil to indicate the user's current or next safe zone range. This is achieved by drawing two circular circles, one based on the radius of the safe zone, and the other a little smaller than the safe zone, and then subtracting these two circles to get what looks like a circular line. Create a parameter named SafeX. This is used to indicate the x position of the center of this circle. Create a parameter named SafeY. This is used to indicate the y position of the center of the circle. Create a parameter named SafeRadius. This is used to indicate the radius of the circle. Set the radius value to 0.5. Add the ideal gradient exponential node. Connect the UV. The center point is calculated in the same way as drawing a Ford circle. Set the radius. Add a custom with the value set to 512. Set to the density. Add the add node. Add the newly drawn circle to the UV. In the preview, we set that a wet circle has been drawn. Next, we draw another circle slightly smaller than this one. Add the radial gradient exponential node. Connect the UV. Connect the center point coordinates. Connect the radius. Connect the density. Subtract a value, use the radius. Set the radius. Subtract a small circle from a larger circle. Set to the add node. You can see that a wet circle is generated on the preview screen. It is not displayed by default. Set the SafeRadius value to 1. Add a comment. Hello everyone, I'm Big Cat. This lesson is about creating a safe zone display logic function. Open the graph of map UI. Get the safe zone object via game mode. Call the function that sets the material parameters. Get the scale 3D of the safe zone. The scale of the safe zone is 1 meter if it is 1. Both the x and y value represent the diameter of the circle. Multiply the diameter by 100 to standardize the units to centimeters. Divide the diameter by 2 to get the radius. Divide by the total length of the map. Set. The parameter is set to zoom radius. Open the safe zone data table and add some data. Run the game. Open the big map. The safe zone is shown, and it can be scaled according to the size of the safe zone. Add a comment. Next, set the location of the safe zone. Add the sequence node. The functions that set the material parameters are called. One is zone X, one for zone Y. Get the location of the safe zone object. Subtract the center location from X. Then, divide by half the total length of the map. Get the x-axis percentage. Set to zone X. Zone Y and zone X are calculated in the same way. Add a comment. Run the game. Open the big map. The display is correct. Add a comment. Safe zone lines are updated each time a reduced safe zone is determined. Create a function named updateSafeAreaState. Add an input parameter named diameter of type float. This is used to indicate the value of the diameter of the safe zone. Add an input parameter named position of type vector. This is used to represent the position value of the safe zone. Set the radius of circle. Multiply the diameter by 100 and convert the units to centimeters. Divide by 2 to get the radius. Divide by the total length of the map. Set. Then set the XY position. Subtract the center point coordinates using the x value. Divide by half the length of the map. Set to save x. Copy and paste. Connect the y value. Subtract -171670. Set to save y. The safe zone will eventually shrink to nothing, and the diameter will be 0. Here, we can't set the reduce in the UV to 0. It will cause the map to go black. So, make a judgment call, and if the diameter is 0, set the diameter to a very large value. Add the sequence node. Determine if the diameter is 0. If not, promote the diameter value to a variable named final diameter. If it is 0, set the final diameter value to 999900. Use the final diameter value for the calculation. Open my game modes event graph. Update the white circle of the safe zone above the map each time you perform a safe zone shrink. Get my HUD. Get the map UI for the big and small map. Call the update safe zone states function. Set the position. Set the diameter. Add delay node. Run the game. The white circle will appear each time you shrink the safe zone. This lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about creating a function to display the bombing area on the map. Open Map UI. Create a radial gradient exponential node. Create two variables named bomb x and bomb y. Indicates the position of the bombing areas, circles x and y. Divide x by 2 plus 0.5. Divide y by 2 plus 0.5. From a vector of x, y values. Set to the circle. Create a variable named bomb radius. Represent the radius of the bombing area circle. Set this value to the circle. Create a constant. The value is 512. Set the density given to the circle. Set the UV. Set the color to this circle. The color values are 1, 0, 0, 0.8. Add node. Connect the nodes. Add comment. Open graph in Map UI. Create function named addBombArea. Add input variable named diameter tab float. Indicates the diameter of the bomb area. Add input variable named position of tab vector. The logic is the same as the zone logic. Open the update safe zone state function. Copy. The diameter unit is the centimeter, so there is no need to multiply by 100. Connect the diameters. Connect the position. The radius parameter name is set to bomb radius. The x parameter name is set to bomb x. The y parameter name is set to bomb y. Open event graph in my game mode. Copy and paste. Call the addBomb area function. Get the bomb area radius via my game instance. Multiply by 2 and set to the diameter. Get the position via player character. Call start bombing. Open map UI. Rename the bombing zone color variable first. Set the safe zone color to blue. Go back to my game mode. Modify the call function to add bomb area. Run the game. When the bombing area is generated, the bombing area circle is displayed on the map. Open the graph in Map UI. Create a function named removeBombArea. Set the radius of the bombing area to 0. Open the event graph of the bombing area blueprint. Call the removeBombArea function before destroying it. Run the game. At the end of the bombing area, the bombing area is removed. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson is about making fight routes displayed on the map UI. First, make the display route. Create a widget in the UI map folder. Name it Airline. Add an image component and uncheck its variable. Set the image to the root. Check set to content. Set the anchor point to the center. The length needs to span the entire map UI, so the Y value is 5000. Modify the image display to be a vertical tile. Modify the X position to 0 and the Y position to 0. Set the X axis alignment to 0.5 and the Y-axis alignment to 0.5. Open the designer in Map UI. Drag in an airline into the overlay. Set the horizontal orientation to the center. Set the default to hidden. Next, create the display logic. Create a function named createAirline. Add an input parameter named startPoint of type vector. This indicates the starting position. Add an input parameter named airplane rotation of type rotator. Indicates the rotation value of the plane. The route's starting point is calculated in the same way as the position of the character icon. Set the render translation of the airline. Open event graph and copy the blueprint for calculating the character position. Use the start point parameter. Set the x and y. Add a comment. Add set angle. Use the z-axis rotation value plus 90. Set the give angle. Add comment. Hide the display of the route on the big map UI when the player jumps off the plan. Create a function named removeAirline. Hide the route. Open the jump off function of my player controller. Call the removeAirline function. Open the map UI. Set the display. For this lesson, thanks for watching and we'll see you next lesson. Hello everyone, I'm Big Cat. All the features in this set of lessons have been completed. In the previous lesson, test scenes were used for efficiency. Next, we switch to the whole scenes. Let's start by setting up the game mode. Open the level battle level. Open the world setting window. Set the game mode to My Game Mode. Run the game. Operate correctly. Open event graph for my game mode. Cancel the execution function. Open Might Map UI. Set to minimap. Run the game. The big and small map has been changed to the new map image. Since the map size has changed, the map's center point has also changed. Open my game instance. Add a variable named map center location of type vector and a category map. Set the center point x value to -1700, y value to -10434, and z value to -6655. Open the event graph of map UI. Get the game instance. Use map center location. Use map center location. Use map center location. Open the add bombing zone function. Use map center location. Opens the create route function. Use map center location. Open the MyGame instance. Add a variable named map half size. Type float category map. Indicates half the size of the map. Set the value to 254000. Open event graph of map UI. Set the default zone value for the small map to 0.05. Use map half size. Use map half size. Use map half size. Multiply by 2. Open the update safe zone state function. Use map half size. Use map half size. Use map half size. Multiply by 2. Open the add bombing area function. Use map half size. Multiply by 2. Open the create route function. Use map half size. Run the game. The big map and the small map. And we'll see you next lesson. Hello everyone, I'm Big Cat. This lesson starts with adjusting the fight route. Open my game instance. Set line 1 min to -223000 -6100. Set line 1 max to -22300 -2100. Set line 2 min to -4000 -23000. Set line 2 max to 0 -23000. Set line 3 min to 23000 -13700. Set line 3 max to 23000 -9700. Set line 4 min to -3900 21600. Set line 4 max to 100 216000. Run the game. The route is correct. Open event graph of game mode. After entering the scenes, the character is in the character preparation phase, and no items are generated. At this end of the countdown, the character gets on the plan, generating items. Disconnect generated items. Open my HUD. After the countdown UI is created, it is displayed. Call to set the time variable. Set it to 5 seconds. Open my character's event graph. Copy fight-related nodes. Go back to game mode. Start fight at the end of preparation. Add comment. Connect generated items. Open airplane blueprint. Set the earliest jump to 0.05. Set the latest jump to 0.95. Run the game. When you enter the scenes, a countdown starts. When the countdown is over, start the flight. Turn on my game mode. Next, set the data for the safe zone. 5 seconds after the captor gets on the plane, turn on the safe zone function. Add a comment. Find the start safe zone function. Use map center location. Set the diameter to 6500. Open the safe zone date table. Reset the data. Run the game. Flat and safe zone function correctly. Next, set the data related to the bombing zone. Open my game instance. Set the bombing interval to 50 seconds. Set the number of bombing zones to 2. Set the bombing zone radius to 30000. Set the number of blasts to 80. Set the duration of each blast to 5 seconds. Open event graph of my game mode. Add the delay node. Set the time to 10. Call the open bombing zone function. Add a comment. Next, set the date related to the airdrop. Open my game instance. Set the airdrop interval to 30 seconds. Set the number of drops to 5. Set the number of items in the airdrop to 2. Open my game mode's event graph. Add the delay node. Set the time to 20. Open the drop 20 seconds after the game starts. call the open